If you want to check out the live stream yourself, it's going to be over at YouTube. Let me get the link. And I need to lock down the room a little bit. It should be at this link right here. Let me go ahead and get that for everybody. Okay, so let's start. All right, everybody, this is HackerFrogs After School. So what is this? We're going to be learning about digital forensics in this first course. So the first course is going to be about 8 classes long. We're going to have these classes every Monday, Wednesday, and Friday. And it's going to be about, they're going to all start about this time. If you could show up about 5 minutes before the class starts, that would be great. That would help me out a lot. Because I'm going to try to go for about an hour, maybe a little bit more than an hour, and then we'll finish each class. So this is digital forensics. Let's talk a little bit about this. Okay, so welcome to HackerFrogs After School. So HackerFrogs After School is a cybersecurity program for learning beginner cybersecurity skills across a wide variety of subjects. This is the intro to digital forensics. So we've got some people in the Twitch live chat. Ronan, hello, nice to see you here. And I'm just teaching a little class on Zoom. So if you mention me, if I mention talking to some people that are not in the chat, then they're in the Zoom call. Okay, so what is digital forensics? So according to Wikipedia, digital forensics is a branch of forensic science encompassing the recovery, investigation, and examination and analysis of materials found in digital devices, often in relation to mobile devices and computer crime. So we're not going to be investigating crimes over here because we're just doing an educational course, but we're going to be talking about some forensic stuff. The study of digital forensics, sometimes called DFIR or digital forensics, or just called forensics in cybersecurity, often deals with the locating and analyzing important data contained within specific types of files, entire file systems, or within computer memory storage. Okay. So in our workshops, we'll be learning how to conduct forensics on different file types, including digital picture files, system memory files, and disk image files. So basically, we're going to be investigating a lot of different files and seeing if we can find some hidden information in there. We're going to be talking about CTFs. Let's see, can you make your screen the full view? I only see a small tile of your screen. You only see a small tile of my screen. You should be able to see the PowerPoint presentation over here, and you should be able to see the background. So it's going to be some cherry blossom trees. You should be able to see some birds and stuff, and you should be able to see my avatar, which is the green frog in the bottom corner of the screen. If you don't see that, let me know. And if to anybody else, if you could tell me if you can see everything or if you can see just a little part of the screen, let us know in chat, okay? So, sorry, what were we talking about? So, HackerFrogs After School classes. Okay. So Vandencourse says, see it all? Okay, it's just small. It's just small. I think, Opal says they could be in gallery by accident. Gallery view by accident. Maybe. Let's see, on YouTube, Cliche says, looks great. Okay, great. I think it might be something on your side, Tornado. Right. Okay. All right, good. So HackerFrogs After School classes prefer to incorporate CTF games into classes for a more interactive experience. But what are CTFs? So when you're talking about cybersecurity, you're going to hear a lot about these CTF things. What are these CTFs? So cybersecurity captured the flag, or CTF games. They're training exercises where the goal of the exercise is to capture the flag through use of cybersecurity skills. So you're basically playing a game where you're supposed to capture a flag by using your cybersecurity skills. And in this context, capture means to gain access to a file or other resource, and flag refers to a secret phrase or password. So the flag is a secret phrase, and capturing is what you do with your cybersecurity skills. So the CTF game we're going to be playing to learn basic digital forensics is called PicoCTF, which is one of the most well-known and well-respected CTF games and is affiliated with Carnegie Mellon University. So Carnegie Mellon University is a big university in, I think, Pennsylvania? I think it's Pennsylvania, but I could be wrong. The PicoCTF game is made up of many challenges across different categories and difficulty levels. For our purposes, we'll be looking at PicoCTF challenges in the forensics category. Okay, so we're going to be learning about, we're going to be starting our journey into digital forensics now. So let me go ahead and switch over to the next PowerPoint presentation. Okay, so hey there, HackerFrogs. This is the first Intro to Digital Forensics workshop. Let us begin. So we're going to be talking about digital image files, otherwise known as thank you very much on YouTube, Cliche, for subscribing. Thank you very much. You're now HackerFrog. Okay, so digital image files, otherwise known as digital picture files, and this is the topic of today's class. So digital pictures, there are a few different ways information can be hidden in these type of files. So let's go ahead and talk about that. But before we talk about that, I'm going to introduce a couple of concepts. And the first concept is EXIF and image file metadata. So metadata is data that provides information about other data. So basically, metadata is data about data. And a lot of files have information about the file itself inside of the file. So in the context of digital image files, each file has a plethora of metadata information, which is generated when the picture is taken. And this kind of stuff can include where the image was taken, otherwise known as the GPS coordinates. It can include where the image was taken, what date and what time the image was taken, and the type of device used to create the image, such as the manufacturer and the model of the device that was used to make the image. So for photos, this metadata is called exchangeable image file format, usually shortened down to the word EXIF. The EXIF standard is associated with digital cameras, smartphones, and scanners. While EXIF data is useful for archival purposes, this metadata poses a serious security risk when image files are shared, especially when uploaded to the internet. The most obvious example of risk is the abuse of EXIF data, which could allow third parties to discover a person's residence or neighborhood through GPS metadata. So if you've got a picture and Kmark, hello, on Twitch, hello Kmark, nice to see you here. We're just doing a little class right now. So if somebody were to capture an image file like a picture and it still has the GPS metadata, they could find out where the image was taken, and that would be a really bad thing. Thank you very much for subscribing on YouTube. Hi, that's a great name. Okay, so let's start our first challenge of the day. So in each one of these classes, we're going to get a chance to do hands-on with some CTF challenges, and this challenge is going to be over at PicoCTF. So let me go ahead and get so if you're not logged into PicoCTF, you want to do that right now, and we're going to be accessing this challenge right over here. I'll be leaving the link for the challenge in the chat. Okay, so everybody, this is the link. And if you want to follow along, you want to go ahead and click into that link to access the challenge. So actually, before you access the challenge in the PicoCTF platform here, I'm going to show you how to activate your web shell. So the web shell is a Linux machine that you can use to solve PicoCTF challenges. So let's just go away from the challenge right now, and I'm going to show you how to open up the web shell. So after you've logged into PicoCTF, you want to click on the practice page right over here. So click on practice, and then after you've clicked on practice, you want to click on the web shell button. So the web shell button, if you don't see it, you want to scroll down a little bit in the web page, and then you want to go over to the right-hand side of the screen, and there's a button labeled Web Shell. Go ahead and click on that. So after you do that, you're going to see this little box open up. It says Starting Web Shell Session. So The problem with the web shell session is the web shell session is in this little box here, and we really want the web shell session to be nice and big. Cliche on YouTube asks, what's the difference between PicoCTF and HTB Hack the Box? PicoCTF is a lot more beginner friendly than Hack the Box is. So PicoCTF is good for people just getting into cybersecurity and CTFs. So we've got this small little box here. What we want to do is we want to make it nice and big. So in this box here, we can click on this button here beside the help button. To the right, it's called Pop Out Web Shell Terminal. This is going to make the web shell terminal nice and big in its own browser tab here, and this is what we want. So if for some reason it doesn't work for you, it might be because the server for PicoCTF is not responding. You want to wait and try again after a few seconds, and eventually you're going to get to this point here, where you've got your nice and big web shell. This is what you want. After you've done this, you can give the clear command, and then the welcome message is going to disappear. So everybody, I want you to go into your PicoCTF web shell, and after you've gone to the web shell and you see this prompt here, so your username -PicoCTF, then I want you to type in the chat web shell up. So just type web shell up when your web shell is ready, okay? Just like that. So if you're having troubles, please let us know in the chat and maybe we can help you out. Okay. All right, so Venting Horse says web shell up, that's great. And let's go ahead and go back to the PicoCTF webpage. So we're going to be doing challenge 180, what was it? I can just look this up, information. Opal asks, how do I clear the screen? So just type clear in the terminal there. So type clear, C-L-E-A-R, and then hit enter, and then that'll clear the screen. And one more time, the information challenge link is over here. Let me just go ahead and get that. Okay, user A says, sorry I joined late, my school ends. Okay. So to user A, if you could rename yourself, that would be great. I've noted that you're here. Right now we're doing challenges over at PicoCTF. If you don't have an account over at PicoCTF, I'll give you a link right now where you can register for an account. Oops. Yeah, okay, that should be it. So how do you change your name? So I think you can right-click on your own icon in the Zoom call and then change your name from there. But if you don't have an account, you can make an account for PicoCTF at this link. Okay, so for everybody else, let's go ahead and take a look at the challenge over here. So this is the first challenge of the day. We're taking a look at this this forensics challenge. It's called Information on PicoCTF, and the description for it says, files can be changed in a secret way. Can you find the flag? And we've got a link for a cat image. So if you were to just click on the cat image, then it'll download the file, and you can see there's a cat over here. That's great. But we're not here to look at cat images. We're here to get some information about this file. So what I want you to do is I want you to copy the link for the file. So after you've come to this page here, you can right-click on the link, and then you can select Copy Link. So select Copy Link, and then I want you to go over to your PicoCTF web shell. So the web shell and the website should be in different tabs in your browser. So once you get into the web shell here, what I want you to do is I want you to download the file. So to download the file, we're going to use the wget command inside the terminal. So it's wget and then space, and then right click and then select paste. So that's going to copy in the file address for the cat file here. And user A, if you're having troubles, let us know, because user A, have you done HackerFrogs before? If you have, and also let us know if you have an account over at PicoCTF. Okay. So let me illustrate one more time really quick. Actually, user A, let me know when you've registered for an account and are logged into PicoCTF, and then I'll show you how to open up your web shell. Okay. But yeah, so the command is going to be this one over here. So it's going to be wget and then this over here. So wget space and then right click and paste in the file address. So after you've done that, you'll download the cat.jpg file. So everybody, if you're following along and you manage to download the cat.jpg file, so you get the contents of the current directory by using the ls command. So ls stands for list, and it'll list out the directory. If you've managed to successfully download the cat.jpg file, it'll show right over here. And if you've done it successfully, please type in the chat, "I got the cat." Modish on YouTube, hello Modish, nice to see you here. We're just doing a little class right now, so I'm not going to be super paying attention to YouTube and Twitch because I got to pay attention to my students who are on a Zoom call right now. User A says, "I'm in. Where do I go now?" Okay, so after you've logged into PicoCTF, what you want to do is you want to click on Practice. After you've clicked on Practice, then you're going to scroll down a little bit and you want to click on this button right here that's labeled Web Shell. So click on the button labeled Web Shell. It's going to be on the right hand side of the screen. If you can't see it, you want to scroll down a little bit and then you'll be able to see it. Click on the Web Shell, and then the Web Shell is going to appear in its small form, but we want to see it in its big form. We want to have the Web Shell in its own browser tab. So what you want to do after you've clicked on the Web Shell button is click on this button beside the Help button. It's called Pop-out Web Shell Terminal. So go ahead and click on that, and you should be able to get the big web shell that takes up the entire screen in your browser. Okay? All right, so let's after we've downloaded the cat.jpg file, what we want to do is we want to examine the EXIF data. So we talked about EXIF data a little while ago, and EXIF data is basically metadata, data about the data. So there's a tool called EXIF tool that can be used to examine the EXIF data inside this file. So after you have the cat.jpg file in your directory, type out EXIF tool space cat.jpg. And then after you do that, hit enter. And what this is going to do is it's going to give you all of the EXIF data. Okay, user A says, "I can't seem to find the web shell." Okay, let's illustrate it one more time. So after you've logged into PicoCTF, click on the practice button. After you've clicked on the practice button, you should see all of the challenges that you can access. From here, scroll down a little bit, and then on the right side of the screen, you'll see this button labeled Web Shell. Click on the Web Shell, and then you're going to see this this box appear. So this is the web shell, but it's in its small form. What you want to do after you've accessed this small web shell is you want to click on this button beside the Help button that's labeled Pop-out Web Shell Terminal. So click on that, and then you're going to see the web shell in its bigger form, which takes up an entire browser tab. So after you've done that, let me know after you've opened up your web shell. User 3 says, "How do I get the cat image to the web shell again?" Okay, so let's illustrate how to get the cat image. Okay, so what you want to do is you want to go to the, okay. So user A, please let me know what device you're using right now. Are you using a Mac computer? Are you using a Windows computer? Are you using some other? Okay, okay. You're using a web browser right now, right? You should be able to scroll down a little bit and then see the web shell button. If you can't, you need to double check if you're logged in or not. You need to be logged in before you can see the web shell button. Okay, so to user 3, who asked about how to get the cat image, what you want to do is you want to get access to this page right here, and the page is this one here. I'll leave the link. And after you're on this page, you should see the information challenge. There should be a cat link right here, cat.jpg. You want to right click on it, and then you want to select copy link. After you do that, you want to go to your web shell, and then in your web shell, you want to type wget. So wget is the command we use to download files. Right click, select paste, and that's going to paste in your file address for the cat.jpg file. So after that, hit enter to download the file, and that's how you get the cat.jpg file. But one more time, we're using exiftool to take a look at the cat.jpg file. And in the cat.jpg file, there's a bunch of information here. So this is metadata. The metadata tells you all sorts of information, like what kind of file this is, when it was made, the file permissions, and interestingly, okay, user A, that's great, that's great. All right, so from here, you want to download the cat.jpg file. So click into the link that I provided to everybody that ends in 186, so it's challenge 186. Click into that. And then I want you to right click on the cat.jpg file here and select copy link. Then go over to your web shell and do the wget space, right click, paste in this command, paste in the file address, and then hit enter, and that'll download the file that we want to look at. So inside the metadata here, there's something interesting. The interesting thing about the metadata is that it's in the license value over here. We've got some stuff that we don't recognize. And what this is something we're going to encounter a lot when we're doing these cybersecurity CTF challenges. And that's base64 encoding. So let's talk a little bit more about this before we move on. So base64 encoding is a type of an encoding system. So it basically transforms data into other data, and it's a widely used encoding method which is used to transform file and picture data for transmission over computer networks. So basically, we can't just send files across a network. We have to transform the data into something that can be moved across those computer networks first. And base64 is one of those systems. So it transforms text and or data bytes into strings like the ones illustrated above. Base64 also features a lot in CTF challenges and is used to disguise information. So for example, I can give this command in Linux. It's going to be like this. This will be encoded into base64, and it's going to turn this message right here into this series of this text string right here. So in the example above, the text this will be encoded into base64 is transformed into the string underlined in red. So we're going to encounter this a lot, so we're going to need to learn to identify this. So base64 strings can be identified as a string of characters composed of any of the characters located in this encoding table. So basically, the characters we see in these base64 strings is going to be uppercase letters, lowercase letters, all of the numbers, and the plus and the slash sign. So if we see something like this, then we can probably identify that this is a base64 string. So the encoding strings also contain the equal sign if the encoded string character length is not evenly divisible by 4. Another obvious sign that something is a base 64 string is that it's a bunch of letters and numbers with an equal sign or a couple of equal signs at the end of it. So in the underlined string, the character length is 43 without the equals character, so one equal sign is added to the end so that it equals 44 characters. Okay, so let's talk a little bit about the contents of picture files. At an abstract level, files contain either human-readable texts or non-human readable data. So this is inside of computer terminology, this is either text or data. Sometimes the data is also called binary data. It's basically data that human people aren't supposed to read. So in this is an example of text file contents. It is intended to be read by users, that is people. So this is example text. We're going to make this text in the notepad file here. And this is an example of data file contents. So it is not meant to be read by people, rather it's supposed to be read by machines, computers or software. And basically if we open up any of our programs that are not supposed to be read by people, it's going to be a bunch of stuff that we can't read. So in digital picture files, the majority of their contents are non-human readable data that is intended to be read by an image viewing program or web browser. Sigma, hello, nice to see you here. And yeah, I'm just doing a little class on digital forensics. If you want to catch the beginning of the class, you can go ahead and go over to the YouTube and rewind to the beginning. So when one of these digital picture files is opened in one of these programs, the file's data is read and the image appears on the screen. However, there are often text strings present inside these image files. So let me illustrate over here. So in the web shell, we've got the cat.jpg file. So if we just try to use the terminal to read this cat.jpg file using the cat command, interestingly enough, we're going to see that it's a bunch of stuff that we can't read. So this isn't opening it with an image reading file. So we can't read any of this stuff. Okay, so let's go ahead and finish the first challenge. So to finish the first challenge, remember we used our exif tool command to take a look at the license, at the metadata, and we found this in the metadata. We're going to go ahead and copy this, and we think this is a base 64 encoded string. So it's basically hidden data. What we're going to do is we're going to give this command here. So it's echo, so that we're going to put this string. We're going to print this string out, but we're also going to base 64 decode it. So this is the command we're going to do. First, we're going to echo out this string that we think is base 64 encoded. Then we're going to give it a pipe right here. So the pipe is basically feeding the information of one command into another command. And we do that with the, it's the shifted version of the / key on your keyboard. And then we give the base 64 decode command. So it's base 64 space -d for decode. And when we give this entire command, we're going to get the flag for the challenge. So the flag for the challenge is PicoCTF, the metadata is modified. So everybody, if you're having trouble remembering this command, I think you should be able to copy and paste this command from the chat in Zoom, if you're one of the Zoom students. So go ahead and copy that. I think, hold on. If you can't copy and paste it, that's fine. What I want you to do is just, whoops. Try giving that command. So what you want to do is from the exif data content here, under license, highlight all of this over here and select copy. Then echo and then paste in the string, then space, then pipe, then space, base64, space, -d. And that's going to get you the flag. What I want you to do now is finish the challenge. Let's see. User A says, where can I find the video? Okay, so if you want to watch the YouTube stream is going on right now over here. And I'll just paste in the link for you. So you can scrub back and forth in the YouTube stream, and hopefully that'll help you catch up if you need to catch up. Okay, so to everybody else, go ahead and after you've given the command here that decodes this string, this is the flag for the challenge. This is what we need to complete the challenge. Highlight it, and then select copy, right-click, select copy, then go back to your challenge. So this page here, there's going to be a little flag submission field at the bottom here. Paste in the flag, and then click on the Submit Flag button. Okay? And that should complete the challenge. So everybody, if you manage to successfully complete the challenge, please type into the chat, cat got. Okay. So if you need to catch up and you're having a little bit of trouble, please let us know in the chat. Maybe we can help you catch up. But in the meantime, let's go ahead and move on to the next challenge. Okay, so we're just talking about the contents of image files. Most of the files in the in image files, they're not able to be read by humans. Cliche, great. Nice to see that you're following along. Okay, so if an image file is opened with a program that isn't designed to read image files, then the contents of the file are going to appear to be gibberish. Okay, let's do another challenge over at PicoCTF called Glory of the Garden. So let me go ahead and get the link for that. Glory of the Garden. And let's copy the link for everybody. Okay, so in this challenge, there's another picture file. So the word garden is actually a link. If we click on that link, then it's going to download the file. And if we open the file, we see that the image is actually this picture of, it looks like some sort of botanical garden, maybe in like an indoor one. But anyways, we're looking for hidden information inside this image file, right? So what we're going to do is we're going to copy and download this file. So inside the challenge, right-click on the word garden and then select Copy Link. After we've done that, go back to your web shell. So in the web shell, we're going to use the wget command again. So wget space, right-click and then select Paste. That's going to paste in the file address. So after you've done that, hit Enter, and that's going to download the file. After it's done, you're going to have the garden.jpg file in your current directory. So if you go ahead and try that. When you've finished downloading the file and you do the ls command and then you see garden.jpg in here, please let us know in the chat by typing in got the garden. Just like this, just so I know that people are managing to follow along. So got the garden. And if you're having trouble, there's no problem with if you're having trouble. Just let us know. Just let us know in the chat, and we'll try to help you out. Okay, user 3 has got the garden. Great. Techno has got the garden. AI Watchdog got the garden. Great. Okay. let's go ahead and talk a little bit about what we're going to be doing to solve this challenge, okay? Where are we? Here? Okay. So we're going to be talking about the strings command in this challenge here. So strings is a very commonly used Linux command. It's basically used to return human readable text. That is, those are known as strings, and we get them from the files. So it's used to return text from files that contain both data bytes and text. That is picture files. So picture files usually have some text, but they also have a lot of data bytes. So this is where we use the strings command. So when we run the strings command by itself, it returns all of the strings in the file, which often isn't useful because there's a lot of random bytes in files that can also be interpreted as ASCII characters, otherwise known as text. So what we can do instead is we can run the strings command with a certain number, with a dash, and that's going to retrieve only strings that are over a certain length. And that's going to help us out a lot when we're trying to get the contents of these files. So let's go ahead and go back to the web shell. So in the web shell, we've got our garden.jpg file here. We could also use the EXIF tool to examine the garden.jpg file. And this is going to be a bunch of information about this picture. So we can get a lot of information about the picture by using the EXIF tool, but there's nothing, that's not where we're going to find our flag for this challenge. What we're going to do instead is we're going to run strings to try to get all of the strings from the file. So it's going to be strings garden.jpg. So it's just strings space garden.jpg. This is going to retrieve all of the text strings from the file. So we can see here that we've got a lot of random little bits of human readable strings, but at the end over here, there's going to be this message here. Here's a flag. And they've got PicoCTF, and this is the flag for this challenge. So an interesting thing we can do with the strings command is we can also give it with this number over here. So for example, maybe -10. That means that we're only going to return strings that are over 10 characters long. Okay, so we got an ad break. We got an ad break on YouTube and on Twitch. So what we're going to do is we're just going to take a minute to wait for all the ads to pass by on Twitch and YouTube. Okay, and while we're taking our break, you can go ahead and type any questions you have in chat. If you're having troubles, let us know. We're taking a 1-minute break, and during the break, we're going to put on our birds because I've got a bunch of bird videos over here. And I like putting on the bird videos when we're taking our break. So we'll be back in about a minute. We just have to take an ad break right now. Okay, and if you have any questions, please type them in chat, and I'll help you out over there as soon as I can. Okay, so it looks like the ad break is just about over, so let's go ahead and put the birds away, and let's continue on with the class. Okay, so we just used the strings command to get all the strings from the garden.jpg file. So remember, the command is pretty simple. All you need to do is type in strings space garden.jpg, JPG, and then you'll get all of the human readable strings. What we want to do now is we want to copy the flag. So it's everything from the letter P up until the squiggly bracket over here at the end. Select copy. Then go over to the challenge page over here, Glory of the Garden. We want to paste in our flag, and then we want to click on Submit Flag. And then that should complete the challenge. So everybody, if you managed to complete the challenge, Glory of the Garden, please type in the chat, Garden God. All right, so let's take a look. We're going to try to do one more challenge today. And we might go over time a little bit today because it took a little while to get the class started. One more time, if you're having any trouble with any of the challenges, please let us know in the chat. We'll try to help you out as best as we can. So Cliche on YouTube says, what is strings basically on this end, and at what instances can it help? In metadata extraction for license was reasonable, but the strings weren't even, they were not even readable. So sometimes people will hide data inside of these files, so they can because these picture files can be really big. People can intentionally, whoops, this is not the interface I want. I want this one. Garden.jpg. So this is basically the hex view of these files. Okay, it didn't like that. It didn't like that. It disconnected me. But people can insert words into these picture files, and they can do this as a means of moving along like hidden information. And this is something we can retrieve by using the strings command. But let's talk about our last challenge for today. I hope that answers your question, Cliche. If it doesn't, let me know, and maybe I can try to explain it better. Okay, so the last thing we're going to be talking about today is we're going to be talking about embedded files. So embedded files are files that exist inside of other files. So it's a file inside a file. Embedded files are often associated with archival file types, such as zip and rar files, but embedded files are in a lot of different files. Embedded files can be found in many common file types, such as Word, Excel, PDF, MP3 audio, and various picture files. So inside of a lot of different files, you're usually going to have some sort of thumbnail. So the thumbnail is going to be something that you see when you're just looking at the file in your file browser. And most of the time, these embedded files are like little images, like thumbnail images. Anyways, we're going to be learning more about embedded files with the last challenge of the day. And the last challenge of the day is PicoCTF Matryoshka doll. So let's go ahead and start up that challenge. Let's see, where is the Matryoshka doll challenge? Here it is. Let me get the link for everybody. Okay, there you go. So what is the Matryoshka doll challenge? So Matryoshka doll, the description for the challenge says, Matryoshka dolls are a set of wooden dolls of a decreasing size placed one inside another. What's the final one? So we've got a another downloadable image in this case. Let's go ahead and right-click on the link and select Copy Link. And then we're going to go back to the web shell and download the image one more time. So remember, the command is wget, then space, then right-click, paste in your file path over here, then hit enter to download the file. Okay, so after you've done that, you should have dolls.jpg in your directory. If you do ls, you should see dolls.jpg here. If you manage to download the dolls file over here, please type in the chat, got the dolls. So I appreciate people typing in the chat just to let me know that people are following along and have managed to do steps 1, 2, and 3, or whatever the heck we're doing. User 3 says, got the dolls. Great. Okay. So we're going to be talking about Tornado also got the dolls. Great. GradXT says, I had a Matryoshka archive challenge recently. What made it particularly hard was having to repair the file, the header signatures to extract properly. Oh, okay. That's that sounds like a more advanced challenge than what we're doing right now. But we'll talk about, we're going to be using a particular program to interact with the extracting these images from these big picture files. So before we do that, of course, we can always use our EXIF tool command on dolls.jpg to get some EXIF data about this particular file. So we get a bunch of different information here, but interestingly, there's going to be this warning over here at the end of the EXIF data output. So it says trailer data after PNG IND a chunk. So this was something that made me scratch my head for a little bit. But if you Google this particular error message, this means that there's embedded files. So there are files inside this file. So actually, what we're going to do is we're going to use a program to extract the files and then get the flag. How are we going to do this? So we're going to use the binwalk program. So we've introduced quite a few different programs to examine these picture files today. It's okay if it seems a little bit like I'm giving you a little bit too much information at once. If you find that it's difficult to follow, you can come back and rewatch the lesson one more time, maybe. But if you're having trouble with any one particular program and what it does, let us know in the chat, and I'll try to explain it. I'll try to explain it better for you. Okay, so the binwalk program. What does this thing do? So the binwalk program is a CLI program that is a terminal program that we use for analyzing and extracting data from files. So the binwalk program is used by cybersecurity students and security researchers to analyze and reverse engineer binary executable files as well as other file types. So binwalk isn't just for picture files. We can use binwalk with a bunch of different files. So when we use the binwalk program, we run it with the file, and it returns the contents of that file, identifying embedded files. So if we just use binwalk with dolls.jpg, we're going to see something that looks kind of like this. And each one of these locations over here, these are locations for different embedded files. So there's a PNG image file, there's a TIFF image file, there's a zip archive data file over here. And let's go ahead and demonstrate this. So in the web shell, we run binwalk space dolls.jpg. So all of these programs usually follow the format, the name of the program, and then space, and then the file name that we want to run it on. So binwalk dolls.jpg. If we just run this by itself, it'll give us this information. So this information says that there's a PNG image, there's a TIFF image data right here, there's a zip archive data, and then there's the end of archive. So what we want to do is we want to extract the data from this image file and get access to the embedded data. So what we're going to do is run binwalk -e. So E stands for extract. So -e space and then the name of the file. So it's dolls.jpg. Hit enter. And that's going to extract the data. After you do that, you're going to see that a directory is created over here. It's called _dolls.jpg.extracted. So what we can do is just move into that directory. CD is going to let us move into a directory, and then _dolls.jpg. Remember that you can use the tab key on your keyboard to autocomplete a file name. This is very, very useful. So just start typing the name of a file, and then after you've typed enough, hit the tab key on your keyboard, and it's going to autocomplete the name. So after you do that, you're going to move into this directory. And when you use the ls command to take a look at what's in here, there's another directory here called base images. So we can just use the cd command to move into that directory as well. And then after that, you're going to see another file here. It's called 2_c.jpg. So we can take a look at this file as well with binwalk. So to binwalk space 2_c.jpg. And we're going to see there's even more embedded files in here. So the name of the challenge is Matryoshka doll, and Matryoshka doll is a bunch of nested dolls inside of each other. What we're going to do is we're going to run binwalk with another modifier, and that's going to extract all the images at once. And the way we do this is we're going to do binwalk -e for extract and -m for Matryoshka doll. Well, no, Matryoshka just means recursive. It's going to go inside and it's going to extract the things that are in the thing and extract the things that are in the thing, and it's going to do that over and over again until it runs out of stuff to do. So binwalk -e space -m space 2_c.jpg. So after you give this command, oh, okay, sorry. It should be capital M. Okay, do it with capital M instead. Okay, so after that, you're going to see that a bunch of stuff is extracted, and we're going to move into all of the directories. So a lot of different directories have been created. So you know that something is a directory in this terminal because it's colored in light blue. So cd _2 and then hit the tab key to autocomplete the name. And then you're going to see there's another base images file. Another base images directory. cd space base images. And then there's a 3 extracted directory. So you're just going to move into that directory. There's another base images directory. And then we're going to see a _4 extracted directory. And then we're going to see a flag.txt file. So this flag.txt file is what we're looking for. Okay, so all we need to do to finish the challenge is to read the flag.txt file here. So cat flag.txt. So remember, in Linux, the cat command is going to read files. So cat flag.txt, and we see that this is the flag for this challenge here. So go ahead and highlight the flag here. It starts with P. It ends with the squiggly bracket at the end here. Highlight all of it. Right-click, copy. Then go over to the PicoCTF challenge at Matryoshka doll. At the bottom here, there's this little field here that you can submit your flag. So click into it, paste in the flag, click on Submit Flag, and then you're finished. Okay, so this one was a bit more complicated than the previous challenges, but if you manage to finish this challenge, please type in the chat, got all the dolls. Got all the dolls. Okay, Venting Horse got all the dolls. Great. If you are having troubles with this challenge, let us know, and we'll try to help you out, because we're going to be finishing up the class after this exercise. If you're having trouble, please let us know in the chat, because we don't want anybody to feel lost. Another thing you can do is, if you're having troubles completing the challenges, we've got this GitHub page over here. And in this GitHub page, it gives you the instructions for all the challenges that we did today. I'll just leave this in the chat. So on the GitHub page here, you're going to see some all the instructions for finishing the challenges. So we've got 3 challenges today. So we had PicoCTF information. There's the link for the challenge. If you want to see a YouTube walkthrough video, we've also provided a link for the walkthrough video, and all of the instructions for solving the challenge over here. So for example, for this information challenge rather, you would do step 1, make a directory, and then download the file. all of these code blocks over here, you can click on the box here to copy the command to your clipboard. It's going to make it easier for you to copy and paste. So step 3, examine the file with the exiftool command. Notice that the license value looks like a base64 encoded string, and then this is the command to decode the string. So same thing with challenge number 2 and challenge number 3. Okay, so we're going to be finishing out our HackerFrogs after school portion of the stream in just a little bit. But we're going to be taking, so for the people who are watching on Twitch and on YouTube, we're going to be taking a little bit of a break while I finish out the class on Zoom with the other students. So everybody, we'll be back in a few minutes. I just need to finish out the class with the people in Zoom. But in the meantime, you can watch this awesome this awesome Be Right Back screen and listen to some music. So let me go ahead and put that on. Oh, okay, sorry. So yeah, we'll be back in a few minutes, but enjoy the Be Right Back screen and the music. Okay, so it's just us Zoom people now. People on YouTube and... Okay, everybody, we're back. Let me catch up with the messages on YouTube and Twitch. Sorry for being a little bit slow responding to messages on YouTube and Twitch. It's just I have to prioritize the students that are on Zoom while we're doing the classes, because I'm working with an organization to give those classes to those students. Techno says, so the after-school program isn't just the YouTube playlist. Are there any requirements for joining it? No, there are no requirements for joining the after-school program. But all you need to do is just watch the stream, and we're going to be doing the after-school program for the first hour or so of the stream. And there's a group of students that I'm teaching on Zoom. I don't mind people on YouTube and Twitch participating as well. You guys can go ahead and join in if you want to. That's just fine. But let's go ahead and start the second portion of today's stream. So the first portion of today's stream was the HackerFrogs After School. We did digital forensics. Digital forensics is going to be going on for about 8 weeks. For the next, well, okay. Digital forensics is going to be going on for the next 3 weeks. And then after digital forensics, we're going to move on into cryptography for another 3 weeks. And then after that, actually wait, I think cryptography is going to be 3 weeks. And then we're going to do our network hacking course. So yeah, please look forward to that. CyberNerd Dante says, Web App Wednesday es mi favorito. Nice. CyberNerd Dante, welcome to the stream. We haven't done any video redeems this stream. Let's go ahead and catch up with some video redeems. How about Hack the Planet?
Hack the planet! Hack the planet!
Okay, let's go ahead and get on to our next part of the stream. So the next part of the stream, I'm going to be doing some demonstrations for a few different web app challenges over at PicoCTF. So PicoCTF, we're doing more PicoCTF. Techno says, okay, I thought the Zoom was something else. So the Zoom is another group of students that I'm teaching through an organization. Senior Goomba on Twitch says, what up, my dude? What up, Senior Goomba? Nice to see you here. Why don't you have a Nancat? Here you go. Okay, so what are we going to be doing on for the second hour of today's stream? We're going to be doing some demonstrations for web app challenges over at PicoCTF. And we're going to be doing the following 3 challenges. So the first challenge we're going to do is, what is it called? Trickster. So Trickster is a web app challenge over here that has to do with insecure file upload. And that's going to be the first challenge we do today. After that, we're going to be doing, what are the other two? The other 2 challenges are called SOAP. And the SOAP challenge has to do with external XML entities, otherwise known as XXE. This is another web app vulnerability. We're going to be taking a look at this. And the last challenge we're going to be doing today is called Find Me. Actually, the order of the challenges might change a little bit. I might do Find Me before I do SOAP. But the Find Me challenge, this challenge has to do with insecure. No, this challenge has to do with URL redirection. So let's go ahead and start the first challenge. The first challenge is called Trickster. Trickster, yeah. Okay, so I'm going to be turning these into YouTube videos eventually, so I'm going to have to do my YouTube intros and outros. Senior Goomba says, I'm doing some cyber defenders. Awesome, awesome. Great to hear that you're taking advantage of the cyber defenders platform. Okay, let's go ahead and get into this first challenge. I'm going to have to grab my GitHub files over here. It says HackerFrogs. It is walkthroughs for PicoCTF. This is PicoCTF 2023? No, it's 2024. Okay, so everybody, if you're interested in taking a look at a walkthrough guide for this challenge, It's over here on my GitHub, but I'm going to be talking about the concepts over here over at this. Oh, we got ads. We got ads. Sorry, everybody. We have ads right now, so everybody on YouTube also gets an ad. And we can put on some birds. How about we put on this bird? That's a northern flicker woodpecker. It is great. We'll be back in about a minute. I just need to take a little water break. How's everybody doing? This is so I was asked by the organization I'm working with to start the classes a little bit earlier, so that's why we started at about an hour earlier than we usually do today. But this is going to be the regular thing for the next 2 months or so, because the batch of classes that I'm doing is about it's gonna last for the next 8 weeks. So for people who prefer an earlier start, then that's good for you. Okay, let's put the birds away and let's go ahead and start the challenge. Okay, so the first challenge we're doing is the Trickster Challenge over here. Let's do our YouTube intro. Everybody, this is a guided walkthrough for the Trickster Challenge over at PicoCTF.org. It's a medium level challenge in the web app hacking category from the PicoCTF 2024 event. The description says, I found a web app that can help process images, PNG images only. Additional details will be available after launching your challenge instance. So it says here that the challenge is browser web shell solvable. That is technically true. It's technically true. We'll talk a little bit about this in a second. But anyways, we're going to need access to our web shell to do this challenge. Let me go ahead and set up my web shell environment before we do this. So we've got all this stuff from the from the previous class. Let me just get rid of this stuff. Okay, nice and clean, great. All right, so the first thing we need to do to start the challenge is we need to click on the Launch Instance button over here. So the Launch Instance button is going to start up the web app, and the web app is going to be in a virtual machine. The way the PicoCTF flags work for later years is that every user is going to have an individualized flag, which makes it harder for people to share flags. And that means that we're going to have to start up this virtual machine every time we do one of these challenges for these modern PicoCTF challenges. Anyways, we can access the challenge after we start up the instance. We're going to see the timer over here, and we can go ahead and put the website in a new tab. So right-click on the link, put it in a new tab, and then we can take a look at this page. So it says, welcome to my PNG processing app. That's interesting. So what the app here is supposed to teach us is it's supposed to teach us about insecure file upload. So one thing we're going to do to get ready to one thing we're going to do to take a look at what is in the app is to take a look and see if there's a robot.txt file. So robots.txt is a pretty common file that can be used to make sure that search engine robots only go to certain parts of the website. But one thing about the robots.txt file that is dangerous is that sometimes the robots.txt file can direct people to sensitive parts of the website, which is not what it was intended to do. But anyways, it says here to disallow these two endpoints over here. So the first endpoint is instructions.txt, and the second endpoint that we're not supposed to look at is called uploads. So this is a directory called uploads, and there's this text file called instructions.txt. So that makes us curious, of course. We're just going to go over to the instructions.txt endpoint. So in the instructions.txt endpoint, it gives us some very interesting information here. So the message goes, let's create a web app for PNG images processing. It needs to allow users to upload PNG images, look for the .png extension in the submitted files, and make sure the magic bytes match. It says, I'm not sure what this is exactly, but Wikipedia says that the first few bytes contain PNG in hexadecimal. That is the character, hexadecimal character 50, 4E, and 47. So after validation, store the uploaded files so the admin can retrieve them later and do the necessary processing. So we got a lot of information just by looking at these two endpoints. Let's talk a little bit about what's going on here and what we're going to be doing to complete the challenge. So we're talking about file upload attacks. File upload attacks are a type of web app hack where malicious files can be uploaded to a web server and then accessed on the web app, executing the code within the uploaded malicious files. So basically, we put some bad code in a file and then upload it and then access it, and then we execute the bad code. In order to perform a file upload attack, there are 3 conditions that must be met. Number 1, there must be a way to upload files to the web accessible location, to a web accessible location. This could be via web app or another service such as FTP or SMB. Second condition is, the upload location must be known to us. So uploading a file isn't enough, we have to be able to locate the file as well, because if we can't locate the file, then we can't access the file. And the third condition is, the app must be able to execute code. For example, it has to be running something like PHP or ASP, one of these engines. So the first condition is the file upload condition. The app lets us upload files, and a lot of apps only let you upload files of a certain type. In this case, it must have the .png file extension, and it must include the magic bytes for PNG files. So we're talking about magic bytes. What magic bytes are is a file's magic bytes. These are the value of the first few bytes in the file, which identify what kind of file it is. So this is pretty common for all sorts of different files. The first few bytes in the file identify what kind of file it is, so that the proper program can be used to open it. So for example, here it's .png, and if we look inside of our Kali Linux over here, we got the JPEG file here, right? What we can do is we can take a look at the contents of the JPEG file. And these are the magic bytes for the JPEG files. So a bunch of stuff we can't print out, and then yeah. So most of the time it's not something we can actually see. But anyways, let's see if we can find another type of file where we can take a look at the magic bytes. So I think on my desktop there's a PNG file. So the PNG file is here. We can take a look at, whoops, let's get the head for that. So here, the magic bytes are these ones over here. So 8954E, and we see that it spells out the word PNG. Okay, so the next thing we need to do is we need to check for its code execution condition. So file upload attacks will not work unless the web app executes code in files. PHP is a classic example, and web apps that host PHP files are a good indicator that an app is vulnerable. So we've got the web app over here, and we just want to make sure that this landing page is actually a PHP page. What we can do is we can go up to the address bar and we can type in index.php. So if this is actually a PHP page, then this should come back. So we type in index.php, and this is actually a PHP page. So what we need to do now is we need to prepare a malicious file to upload to the application. Okay, so the very last thing we need to do is we need to have a known upload location. So even if we're able to upload a malicious file and locate it, actually no, upload a malicious file, we need to be able to locate it, because if we can't access the file, then we can't actually conduct this file upload attack. Last condition is the ability to access the malicious file that you upload to the application. So the robots.txt file in this application lets us know that there's an uploads directory. So this is where we predict we're going to be able to find the file after we've uploaded it. So let's go ahead and prepare the file. Okay, so I've got a little walkthrough for this particular challenge. If you want to take a look at it yourself, it's at GitHub over here. So we can prepare our malicious file like so. So the first thing we're going to do is we're going to create a web shell. So a web shell is basically a malicious file that can be used to run arbitrary commands on the web application that act on the web server. So we're going to create a very small web shell with this command over here, and I'll just paste in the chat. We're going to go over to our web shell, and in the web shell, we're going to paste in the command. So we're just going to echo out some contents that we're going to redirect into a file. So the contents of the file are this PHP code, and the PHP code basically says to get the contents of the 0 URL parameter. So the URL parameter that we're going to be using to activate the web shell is 0. We'll illustrate what this actually looks like in a little bit. But anyways, let's go ahead and create this file in the web shell. This creates a file called webshell.php. So we see here that we got our malicious file, and it's got the contents, the PHP web shell payload that we specified to it over here in the echo command. The next thing we need to do is we need to give this file the magic bytes for the PNG file. So remember, the magic bytes are basically the file header that lets a system know what kind of file that it's supposed to be dealing with. And we're going to be using our printf command to insert the magic bytes for PNG files into the webshell.php file. So this is what the command looks like. So we use the printf command to print out these bytes. So these bytes aren't printable, so we have to supply the bytes as their hexadecimal equivalents. After that, we're going to pipe it into the cat command. It's going to take the webshell.php file, and it's going to prepend these bytes here, and it's going to output them into a file called webshell.png.php. Remember that the web application is also checking to see if there's .png in the name of the file. So we're going to submit this file name in order to get around that particular restriction. Okay, so when we run this command, we have a new file called webshell.png.php. If we read the contents of the file, we see that we've got the magic bytes for the PNG file here, and then we've got the web shell instructions in the rest of the file. Okay, so from here, what we're going to do is we're going to export this file. So this is the web shell, the PicoCTF web shell. We're going to download this file, and we can download the file by giving the sz command, then space, and then the name of the file. So webshell.png.php. So that downloads the file, and then afterwards we can upload it to the application. So this is how we're going to do it. We're going to go over to the file upload page. We're going to click on Browse. We're going to select wherever we downloaded, should be in my downloads folder. And we're going to select all files. So all files, we're going to look for webshell.png.php. So you're going to select it. We're going to click on open. So we've got that file selected, and then we're going to upload the file. After we do that, we get this message from the web application. So file uploaded successfully and is a valid PNG file. So we managed to successfully get around both of those restrictions. It says we shall process it and get back to you hopefully. So this is where we need to locate the file. If we can't locate the file, then we can't perform our file upload attack. We know that there is an uploads endpoint because robots.txt showed us that it's disallowing search engine robots from looking in the uploads directory. So we're just going to take a guess that the file is going to be located in the uploads directory. So it's going to be uploads/webshell.png.php. So when we try to access the file, it actually gives us an error over here. The error is because we didn't supply the right information to the web shell. The way we supply the right information to the web shell is we go into the address bar. At the very end of the endpoint here, we're going to give the question mark. So question mark means we're going to start some URL parameters. So question mark 0, and remember we put in 0 in the code. So 0 equals, and then the name of the command we want to give. So 0 equals who am I? Who am I is going to give us the username that we're acting with for the web application. So it says we see here that there's the PNG file header that we supplied in the web shell file here, and then we get the actual output of the command that we gave to the system. Who am I? Which is www-data. So we're working as a web user right now. What we need to do is we need to locate the flag. So what we're going to do is we're just going to do a little bit of sneaking around inside the file system. We're going to give the ls command, and we just see that there's this file in this directory. We're going to see what directory we're working inside, so pwd. So we're in this directory right here. So var www.html. So var www.html is usually the web root of your web page when you're working inside of a Linux web server, so something like Apache. What we're going to do is we're going to take a look at the contents of this directory, but not the uploads directory, because we already know what's in the uploads directory. So it's going to be, the command is going to be ls/var www.html, like this. And we see we've got these contents here. So if we find this a little bit hard to look at, we can always take a look at the page source, so the HTTP source, and this will give us the output in a easier to see format. So we got index.php, we got instructions. We've seen all of this stuff already. So instructions.txt, we read this already. Robots.txt, we read this already. Index.php, we could read this. And we've got this unusually named file right here. So what we're going to do is we're going to read this to find out what the heck is inside of this. So just copy this, and then we're going to run the cat command on it. So the command is going to be 0 equals cat space, then paste in the name of this file. Hit enter. Oops, that didn't work because we need to give the absolute file path. Cat space /var/www/html/ this file name right here. And when we do that, we get the flag. So the flag is PicoCTF certified expert trickster. Okay, awesome. We're going to copy this. Then we're going to go over to the PicoCTF challenge. Scroll down in the flag submission field, paste in the flag, click on Submit Flag, and then we're done. Okay, everybody, this was a guided walkthrough for the Trickster Challenge from PicoCTF, the PicoCTF 2024 event. Everybody, if you enjoyed this guided walkthrough, please click on the like and subscribe buttons on the video and leave a comment underneath the video. But until next time, HackerFrogs out! But we're not stopping the stream. We're not stopping the stream. It's just something I have to say for YouTube. Okay, let's go ahead and start the next challenge, okay? Let's, so we've got our web applications here. We're just going to close these out because we don't need them anymore. I've got so many web shells. Let me try closing out some of these tabs. Okay, I'm just going to do a little bit of cleanup. Okay, nice and tidy. Alright, let's start the next challenge. So the next challenge is going to be called Find Me. So this is a challenge from PicoCTF 2023. Okay, let's go ahead and start the challenge. And everybody, if you want to follow along yourself, you can go ahead and access the challenge from this link. Let me grab the link. There you go. Okay. Everybody, this is a guided walkthrough for the Find Me challenge from PicoCTF. This is a medium level challenge in the web app hacking category from the PicoCTF 2023 event. The description says, help us test the form by submitting the username as test and password as test exclamation point. Additional details will be available after launching your challenge instance. So this is another challenge where we need to start the virtual machine by clicking on the launch instance button over here. After we do that, after a few moments, you're going to see a timer, instance timer remaining, and this is how you know that the instance is running and we can solve the challenge. So we also see a link now, the website running here. We can go ahead and put this in a new tab and then access the challenge over here. So it says, help us test this form, username test and password test. So this is a bit of a rabbit hole. Because it says username test, password test, period. But the challenge says that we need to use test exclamation point as the password. So we got to be careful here. So username test, password test, exclamation point. When we click on confirm over here, it says, welcome fellow human, I was redirected here by a friend of mine, but I couldn't find anything. Help me search for flags. Here's the thing, the flags are not here because the flags were actually the redirections along the way. And let's talk about this concept that we need to understand to finish this challenge. So we're talking about URL redirection in this challenge. So URL redirection is a feature of web pages that causes requests to a web page to be redirected to another web page. So this is what a redirection might look like in the PHP language. So header location redirect.php. Location, it's not always going to be redirect.php. It could be the name of any other web page. But all HTTP response codes in the 3xx range indicate a redirection, and the location header tells the browser which URL to redirect to. So if we get a response to our HTTP request that has 30 something, well, it could be 3 something something, and the location header in the response is going to say where we're going to be redirected to. So let's go ahead and take a look at what happens for this request when we submit this. Let's go back. The funny thing is when we click back on in the browser, it tells us what pages we accessed before. So, interesting. So this is base64 encoded information. And what we're going to do is we're going to recreate this. We're going to take a look at the source code for this challenge. In the source code, it tells us what exactly is happening when we click on the submit button. So we're going to submit a username and a password in a post request. So where does it say post request? I'm pretty sure it says it somewhere in here. Okay, it says method post, and it's going to be to the login endpoint over here. So we've got all the information here to make this request ourselves, and we're going to make it inside of the curl command. So we're just going to go over to our web shell. In the web shell, what we can do is type in curl. We're going to get the URL for this particular website. We're going to paste it in, and we're going to add login to the end over here, because the endpoint we're actually contacting via the post request is the login page. So at the beginning of the curl command, we're going to do verbose. Verbose output is going to give us a lot more information about what happens when we give this request. We're also going to give some data. So the data we're going to give is the username and password. So we're going to type in username equals test and password equals test exclamation point. Actually, when we use the exclamation point, we can't use these double quotes. With the exclamation point in here, we have to use single quotes, otherwise the terminal is going to act really weird. Okay, so when we give this request, curl-v-d, in the single quotes, username equals test and password equals test, to this endpoint, which is the login page over here. These are HTTP request headers. These are the HTTP response headers over here. So this gives us the indication that we're being redirected. So 302 found, it's going to give us the location of the next page over here. And what we're going to do is we're going to follow these redirects using curl. So we're just going to give the same command again, but this time we're going to tack on an extra -L onto the curl command. So -L is going to follow the redirections inside of curl. Usually curl doesn't do redirections. We need to give this additional part of the curl command to have it follow the redirections. When we give this command, then we're going to get all of the redirections here. So our first request results in a redirect, and the redirect is to this endpoint here. And the second redirect, sorry, the second request is going to result in a 200 OK. But even though it says 200 OK in here, there's actually some JavaScript code in here that redirects this as well. And the JavaScript code is this. So this JavaScript code is also going to redirect us to another page. The interesting thing about both of these redirects is that there's a URL parameter in here that looks like base64 encoded information. So what we're going to do is we're just going to grab both of these. So this is the one for the first request. Just going to copy that. Copy that, go down to the end. We're going to echo out this information. Okay, echo out the information, paste in the first part of the code, and then we're going to get the second part of the code over here. Copy that as well, and paste in this information. And then we're going to, well, let me first do this. Okay, we're going to echo out this information, and then we're going to pipe it into base64 decode. So when we do base64 decode, we get the flag. So it says PicoCTF proxies all the way. So all we need to do to finish the challenge is highlight the flag, copy it, then go over to the PicoCTF webpage, paste in the flag, submit the flag, and then we're done. Okay, so before we finish the challenge, let's just do a little review of what we did in this challenge. Okay, we got ads running on Twitch, so we run them on YouTube as well. Let's go ahead and put on a bird video. Okay, this is the bird video with the spotted towhee. Huh. Wonder when the spotted towhee appears. I think it's over here. Okay, so enjoy the birds. We'll be back in about 30 seconds. There we are. There's the spotted towhee. That's the interesting thing about this bird is that it's got these he's got these red eyes. So you might think that the bird looks a little bit scary because it's got the red eyes, but you know what? This bird didn't choose which color eyes to have. But anyways, let's put the birds away and let's go ahead and finish off the challenge. Okay, so this was the Find Me challenge, and the key concept for this challenge was URL redirection. So the challenge asks us to log in with the following credentials: test, username test, password test. After we do that, we are redirected to 2 pages, and the ID parameters look like base64 encoded strings. So we can give this curl command here to follow redirections after we give our credentials here, and then we can put together the base64 encoded strings to get the flag. Alright everybody, that was a guided walkthrough for the Find Me exercise over at PicoCTF. If you enjoyed this guided walkthrough, please click on the like and subscribe buttons on the video and leave a comment underneath the video. But until next time, HackerFrogs out! Okay, let's go ahead and do the last challenge today. So the last challenge we're doing today is going to be... Actually, this is going to be a fun challenge, because this has to do with a kind of underrepresented web app vulnerability that's called XXE, or external XML entities. So let's go ahead and prep for that challenge. I need to prep my environment. I'm going to close down any unwanted browser tabs because we don't want to be too cluttered. And the challenge is called SOAP. So this challenge is actually going to involve us using Burp Suite. So if you don't have access to Burp Suite, then unfortunately you're probably not going to be able to follow along with us. But this is the link for the challenge. Okay, so everybody, let's go ahead and start the challenge. Everybody, this is a guided walkthrough for the SOAP challenge from PicoCTF. It's a medium... Slyborg, hello! I can burp sweetly. I can burp sweetly. That's a funny message, is what it is. Slyborg is here, and they are a fellow content creator. If you want to check out their channel, then you can check out their channel over here. Click on the link, and you will be brought to their channel. There you go. Slyborg, welcome to the stream. We're just going to be covering this web app challenge over here. We're going to be talking about this vulnerability called XXE. So it's a funnily named vulnerability, but let's talk a little bit more about this. So this is a medium level challenge from the web app hacking category from PicoCTF 2023, and the description says the web project was rushed and no security assessment was done. Can you read the /etc/password file? Additional details will be available after launching your challenge instance. So what we need to do here is we need to click on the launch instance button, and that's going to start the virtual machine that hosts this website. So after a few seconds, you're going to see this instance time remaining. So we got 15 minutes. Hopefully that's long enough to finish the challenge. Let's go over to the web portal here. We'll right click and put it in a new tab. So PicoCTF, this challenge involves XXE, and it's probably going to require us to use Burp Suite. So what we're going to do now is we're going to start up Burp Suite in our Kali Linux here. So Burp Suite is a very, very common security tool. It can be used to record web app traffic that you can replay and you get all sorts of other information from. So after you start up Burp Suite, what we're going to do is we're going to start up the Burp Suite browser. The Burp Suite browser is a web browser that's connected to Burp Suite, and all the information that goes through it will be recorded by Burp Suite. So we're going to go over to the Burp Suite proxy tab over here, and then from the proxy tab, in the intercept subtab, we're going to click on Open Browser. So this is the Burp Suite browser, and what we're going to do is we're going to get the website over here. Then Burp Suite browser, we're going to navigate to this website, and we're going to do some investigation over here. So the name of this challenge is called it's called SOAP, but we're told that this has an XML external entities vulnerability. So what's that vulnerability? Let's go over what that is over here. Okay, so we're talking about XXE, which stands for XML External Entities. This is a type of web app vulnerability which targets applications that parse XML, which is a document type. Anytime we can send a post request to an application that includes XML data, that application could be vulnerable to an XXE attack. So if we're able to spot a post request that includes this XML data as part of its post body over here, then we should probably check for this kind of vulnerability. So XXE attacks can be used to read known files on the underlying web server. So we need to go back to the challenge to see what the goals are. So the goal is read the /etc/password file. So if we go over to the application in the Burp Suite browser, we're going to see that there's some buttons over here. And what these buttons are going to do is they're going to send a post request. If we go over to, after we press the button, we can go over to Burp Suite. And in Burp Suite, we can take a look at the HTTP history. So at the bottom of the request that we made, there's this post request that we made to the data endpoint here. So we see here that in this request, we made a post request to the data endpoint. And in the body, we've got some XML data. So this is a pretty obvious indicator that we need to test this application for the XXE vulnerability. So what we can do is we can right-click on this request and then send this to the repeater. So the repeater is the Burp Repeater. This is another tool inside of Burp Suite. And we can click on the repeater afterwards, and we can manipulate this information, and we can send an XXE vulnerability payload to test this application to see if it's vulnerable. So let me demonstrate what this kind of payload might look like over here. Okay, so we press one of the buttons and check out the HTTP history in Burp. In Burp Suite, the post request for the /data endpoint has XML content, and we can use this payload to create an additional entity called example and have it output the contents of the /etc/password file, which is the objective of this challenge. So this is the payload we're going to do. We're going to include to try to get the contents of the /etc/password file. So basically what we're doing inside this payload is we're creating a new entity inside of the XML data here that's called example. So we define example here as a new entity that retrieves the system etc password file. So if we give this payload and there's actually an XXE vulnerability, then we're going to get the contents of this file. So let's go ahead and copy the payload. And if you're wondering where this document is, this is on my GitHub. So copy the payload, then go over to your Burp Suite. In Burp Suite, we're just going to highlight the previous payload, then we're going to paste over top of this. So paste. Okay, so this is the new payload with the malicious stuff in here. Okay, so when we send this request, we're going to take a look at the response. So this is the request, and the other tab is the response. So in the response, we see invalid ID, then the number 2, and then the contents of the etc password file. So we were able to hack this application with the XXE vulnerability, and then we managed to get this information here, which is the goal for the challenge. We've got the flag in here, so all we need to do is highlight this, copy it, then go back to the challenge description page, and submit this at the bottom of the challenge entry here. Click on Submit Flag, then we're finished. Okay, so before we finish, let's do a quick review of what we did for this challenge. Okay. So this was the SOAP challenge. The vulnerability key concept of the challenge was XXE, which is external XML entities. Let's see. From the tags on the challenge, we know that we're dealing with an XXE vulnerability. Since we're looking for post requests, since we will be looking for post requests to find the XML in the request body, we need to use the Burp Suite tool and send requests through the Burp browser to replay the post requests. When we access the landing page of the website, we said that there's some buttons we can push. We press one of the buttons and check out the HTTP history in the Burp Suite History tab. The post request for the /data endpoint has XML content, and then we can use this payload over here to get the contents of the etc password file. Alright, everybody, that was a guided walkthrough for the SOAP challenge over at PicoCTF. And if you enjoyed this guided walkthrough, please click on the like and subscribe buttons on the video and leave a comment underneath the video. But until next time, HackerFrogs out! Alright, so everybody, this is what I had planned for the demo portion of the stream today. If you've got any questions, or if you've got any concepts you want me to explain about web app security, I guess you can leave them in the chat. But what are we going to be doing in just a little bit? We're going to be doing our free hacking challenge. And for the free hacking challenges, we've been going through a series of web app challenges from the Overthewire website, and this is the Natas CTF game. We're getting pretty close to the end of the Natas CTF game. We're currently on level 28. And let's go ahead and change up the music, because I don't recognize this music. Let's play some moody music from, let's see, Independence War 2. It's one of my favorite sci-fi games. Okay, so let's go ahead and yeah. So we've been doing the web app challenges from the Natas CTF game, and if you want to take a look at all of the walkthroughs we've done for those challenges, you can find them over here. The Natas CTF challenge is it's a pretty well-known series of challenges. Natas CTF. Let me see if I can get the main page. Okay. So this is the Natas game, and it says here that Natas teaches the basics of server-side web security. Each level of the Natas consists of its own website located at this website over here, natasx.natas.labs.overthewire.org, where X is the level number. There is no SSH login. To access a level, enter the username for that level and its password. So just in case anybody doesn't know this game, I'll demonstrate the first level for everybody right now. So, okay. What we need to do to start the game, we need to access this URL over here. So, if anybody's wondering what web page I'm looking at, this is the link over here. So it gives you the username and password for the first level here, which is Natas level 0. So what you can do is you can access this link, give the username Natas 0 and the password Natas 0. So we're just going to do that right here. It's going to ask us for a username and password, so we can put in Natas 0 and password Natas 0. Click on sign in, and now we're logged into the Natas 0 level of this particular game. So on this page it says you can find the password for the next level on this page. So don't the levels for Natas they start up very, very easy, and they progressively become more and more difficult until the point where you want to tear your hair out because they're so hard. But anyways. So this page teaches us a very important concept when we're doing web app security. And if you know what that concept is, how would you first try to investigate this web page? So I'll ask people in chat, if you've got a couple of things you do when you first investigate a web page, let us know in the chat. Okay, so GroudXT says view source. That's correct. So if you've got nothing else to go on when you're looking at a web page, Slyborg says the first thing you do is Wappalizer. I think I've got Wappalizer on here. Yeah, we've got Wappalizer. This tells us the technologies for this particular web page, but it's not the first thing I would take a look at. But yeah, Wappalizer is pretty good suggestion. But the first thing we would do on any web page is basically look at the web page source, because in a lot of these easy level CTF challenges, there's going to be stuff hidden in the web page source. So you would just go ahead and either right click and view the page source, or you'd use the Control-U keyboard shortcut. And so the solution for the first few of these easy CTF challenges at the Natas CTF game, they basically involve looking at the source code. So some people, you know, when I was before I learned about cybersecurity stuff, when I would accidentally look at the HTTP source code for a web page, I would get really scared because I didn't know how to read anything in here, and I would freak out. And it's like, what is this? But now I know better. I know better, and I can actually understand some of the stuff that's going on in here. Anyways, it says here in the HTTP comment, the password for Natas 1 is this. GradXT says, stuff's been hidden in JS files, JavaScript files too, so inspect elements sources tab is another good view. Yeah. So if you want to know what kind of files are being used in conjunction with this file, you would also take a look at, you would go over to your web developer tools, so that's F12 I think, to open up your web developer tools in most web browsers. And then you would take a look at the network tab. So there's a bunch of different tabs in the web developer tools here. If you reload the page, you see that this web page makes reference to a bunch of other web pages as well. Well, they're not necessarily web pages, but they're files. So they've got a bunch of these JS files, JavaScript files, that are referenced in the web page source code. This is another interesting thing that you can look up as well. But for this particular level, we get the password for the next level, which is Natas level 1, and it's this password right here. So the levels start up. They start off very easy. By the time you get up to levels in the 20s for this game, they can become pretty difficult. Anyways, I'll demonstrate the next level, and then we'll move on to our actual challenge where we're going to be having a hard time. Okay, so let's go ahead and navigate to Natas level 1. For Natas level 1, the username is going to be Natas1. The password is going to be the password we got from the last level. Okay, so it says you can find the password for the next level on this page, but right-clicking has been blocked. So if we used right-clicking to access the view page source option, then we can't do it on this level. We need to find another way. There are actually a bunch of different ways we can access the page source, but you know, if you've got a suggestion for what other method we could use to see the page source, leave them in chat, and then if it's correct, then I'll say that you're a cool person. So let's see, what other methods can we use to see the page source? I can think of 3 different ways. So Techno says Control U. Yeah, so we can use the keyboard shortcut to take a look at the source code. So we can use the keyboard shortcut, Control U. Another way we could do it is in the URL address bar, we could type in view-source : in front of the endpoint here, and that's also going to get us the source code. Another thing we could do is we could I accidentally clicked out of the thing. Okay, let me go back. Natas1. Okay, we could also go over to the web developer tools. So more tools, web developer tools, and then go over to the inspector. And in the inspector, we can take a look at the HTTP source code here as well. But funnily enough, we actually can't see the source code in here. Sick in the Mind, hello, nice to see you here. Sick in the Mind is a fun viewer of ours, and let's give them a Hack the Planet. There you go.
Hack the planet! Hack the planet! Shut up again.
You know, strangely enough, we can't see comments in the inspector here. That's probably on purpose, right? Oh no, we can see. Okay, we can see the comments here. Okay, so we can see the comments here, and in the comments we see the password. That's great. Let's see. GradXT says we can use Burp Suite to capture all the traffic, and you can analyze it there. Yeah, we could definitely take a look at Burp Suite, and actually we can take a look at it there. We could also use the curl command. There are a bunch of different things we could do to take a look at this information. So we would curl http natas1.natas.labs.overthewire.org. But we also have to give the username and password. So the username is natas1, and the password is, I put the password in the chat. Let me copy it from the chat. Unauthorized. So is it not? Do I need to put this in? Okay, so it's not dash. Is it dash small u? Okay, great. So you just need to use curl with the small u and then supply the username and password. And this is another way we can access the HTTP source. Okay. All right, let's, oh man, now we've got to start our challenge. The challenge is not going to be fun. It's not going to be fun for me, but let's, you can't be afraid when you're doing these challenges. Okay, so we're going to go all the way over to Natas level 28, and this is the password for Natas 28. Let's go ahead and. So this is Natas level 28. This is the password, and let's get the URL for the site. Natas 28. Okay, so Natas 28, password is this. OreoBite is writing with a party of 9. Hello, OreoBite viewers, OreoBite and viewers. Thank you. Welcome, Raiders. Welcome, welcome. Let's give everybody a fun redeem. How about all the things? It's a fun hacker rap. Drink all the booze and hack all the things. Okay, everybody, you've shown up just in time for me to start my my challenge now, and what we're going to do is we're going to try to figure out how to complete this level of the Natas web app series. So Natas level 28, whack computer joke database. 4P44, hello, nice to see you here. And welcome OreoBite and all friends. My name is the Shy Hat, and I do cybersecurity content over here on Twitch. We do demos, we do education, and we do challenges. So we're doing challenges now, and let's go ahead and figure out what's going on in this web app. So whack computer joke database. Search for joke. So if we search for the word joke, what do we get? I've got a really good UDP joke to tell you, but I don't know if you'll get it. This is, wow, I wonder if KenPDX is here. If KenPDX is here in chat and you appreciate this joke, please let us know, because it seems like a joke that KenPDX would really like. No sauce. We don't get the source code for this particular challenge. So the reason why this joke is funny is because UDP doesn't care if you receive the packet or if you don't get the packet. So that's why UDP is about not getting the joke. Anyways, what's another joke we can do? We're out of sauce. We can't get the source code. Which vulnerability do you think this is? Do you think this is SQL injection, or do you think this is something else? How about sauce? Can we search for the sauce? No, there's no sauce. How about we search for, I don't know, computer? Okay, so this is doing some sort of search. We're probably searching inside of an SQL database. So we're probably searching for entries that have this particular word in it. So let's just read these jokes for fun. So a computer lets you make more mistakes faster than any invention in human history, with the possible exception of handguns and tequila. A computer lets you make mistakes faster than any invention in computer history. in human history, with the possible exceptions of handguns and tequila. What is a computer virus? It's a terminal illness. This one's good. I like this one. Okay, we got ads running on Twitch, so when ads run on Twitch, we run them on YouTube as well. And let's go ahead and play some bird videos. How about this bird video? This is the stellar jay that loves the peanut. GredXT says, single apostrophe or asterisk would be some tests I'm thinking of. You know, that's not a bad idea. That's not a bad idea. Okay, so our ads are going to be running for the next minute or so, so we're just going to pause and watch the birds for the next minute, just so nobody misses out on any of the action. So an interesting thing about the stellar jays is that they love shaking peanuts. So when they get a shelled peanut, they'll shake it around just to figure out if it's a good peanut or a bad peanut. I guess they're testing it for density. They don't want a peanut that rattles around too much, so they just shake it around in their mouth, and it's pretty entertaining to watch. Anyways, let's put the birds away. Okay, so let's see. How do you tell an introverted computer scientist from an extroverted computer scientist? An extroverted computer scientist looks at your shoes when he talks to you. So this is a joke about computer scientists being super introverted. Anyways, let's go back. And let's see what GroudXT suggested. Let's go ahead and provide a single quote over here to see if we get an SQL error. So this is one of the ways we test for SQL vulnerability. So it looks like it... Huh. Interesting. So this is a good joke. Knock knock. Who's there? Very long pause. Java. Question. How many programmers does it take to change a light bulb? A. Answer. None. That's a hardware problem. Ha 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 ha. Alright. So it looks like the single quote and the double quote are probably not going to work for this injection. Let's try double quote. So double quote. Let's see. Let's see what jokes we have here. When we write programs that learn, it turns out we do and they don't. Is this an AI? Is this related to AI? It turns out that the AI doesn't learn. Okay, here's a really long joke. The joke is, a physicist, an engineer, and a programmer were in a car driving over a steep alpine pass when the brakes failed. The car was getting faster and faster. They were struggling to get round the corners, and once or twice, only the feeble crash barriers saved them from crashing down the side of the mountain. They were sure they were all going to die, when suddenly they spotted an escape lane. They pulled into the escape lane and came safely to a halt. The physicist said, "We need to model the friction in the brake pads and the resultant temperature rise to see if we can work out why they failed." The engineer said, "I think I've got a few spanners in the back. I'll take a look and see if I can work out what's wrong." And the programmer said, "Why don't we get going again and see if it's reproducible?" Oh, okay. All right. Okay. So the last joke is, an SQL query goes into a bar, walks up to two tables, and asks, "Can I join you?" You've got to program using SQL to understand this. Alright, so let's see. Let's go ahead and try to figure out some sort of characters that are going to break the search. So this broke the search. The asterisk broke the search. I think we could also try semicolon. So semicolon might break the search as well. So semicolon breaks the search. The asterisk breaks the search. What else? What other special characters in SQL could we use? So dot or dash 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 space. Okay, that also breaks the search. And maybe we can try the hash symbol. Yeah, gredXT. Okay, so these all break the search. We're out of sauce, so we can't get the source for this. Maybe we can take a look at the So we got index.php. And we got these. I've seen these messages for a while in the past few levels of the Natas CTF challenge. The problem is that these comments have never really led to any sort of solution. So mostly I've been ignoring them. Huh. So what do we feed to this? First of all, I should probably take a look at this in Burp Suite. So we're just going to go over to the Burp Suite browser. And we're going to log into here. This is Natas28. What's the password one more time? Get the password. Here. Yeah, this one. Okay. So to anybody who wants to join us, this is the link, this is the username, and this is the password. Okay. So this is probably some sort of SQL injection. Let me go ahead and start editing the file. So SQL injection. I can't see how it could be anything else. And what we can do is we can start testing some SQL injection payloads just to figure out what is going to get us a good result. Okay, so we're going to submit the search. Let's do test. Okay, that doesn't, well, Oh, interesting. When we did this, reached out to search.php. So search.php is another page in the application. Let's take a look. What? MEP? What does this mean? What? Okay, so when we did our search, it actually returned at search.php. Meppers. Meppers? I don't know what meppers are. If you could let me know, that'd be much appreciated. So we've got a bunch of URL encoded stuff over here. Maybe this string is vulnerable. So let's go ahead and let's see if we can get something from it. So let's CyberChef. CyberChef, how about URL decode? So we're going to URL decode this thing. Okay, so so this very obviously looks like some sort of base 64. You know, base 64 never goes away. We find it everywhere. Okay, so we got a base 64 string. Let's see if we can figure out what the base 64 string says. this is another base64 string. So do we base64? Oh, no, that was not decode, that was encode. Okay, so, when we decode it from base64, we get all this, all these unprintable bytes. So, I mean, it really looks like base64, but maybe it's not. Maybe, I mean, this definitely looks like base64. Maybe it's separated by these slashes here, and each one of these slashes is going to be something different. So if that's the case, then let's get rid of everything but the very last portion and see if it... Okay, that's still not anything that's intelligible. Huh. Well, you know what? Maybe we can feed this to the AI and see if it has some sort of opinion on it. Okay, Mr. AI. You think you're smart? What could this app URL parameter be hiding? Okay, so it looks like a base64 encoded string. However, base64 encoded strings typically don't include characters like plus or slash or equals in the middle unless they're part of the encoding. So this suggests it could be a cryptographic value such as encrypted data, hashed value, encoded token, obfuscated parameters. Okay, well, let's take a look at it inside of Burp Suite, because we got all these requests in Burp Suite now. So this request here, let's go ahead and highlight this and see what the inspector has to say. So this is URL encoding, it's this. This doesn't give us very much. And what kind of headers and response did we get? Let's send this over to the repeater. Okay, and in the response, well, we need to send this before we get a response. Okay, it looks like... I don't know. I think it's either going to be something in this URL parameter here that that's going to lead to us solving the level, or it's going to be SQL injection. And I'm thinking the more I work at this, the less likely I think it's going to be SQL injection. But, you know, just for fun, we should probably throw SQL map at it. The comment, yeah, the comment there seems a bit unusual. So P44 is talking about this over here. Morla something something something. So we've seen this kind of comment in the past few challenges, but in the past few challenges it doesn't seem to be... This doesn't seem to be relevant. So I don't know. I don't know if this is actually part of the challenge or not. So what can we do from here? We can probably throw some... We can probably throw some SQL map at it. So I'm going to go ahead and save this out as... Let's see. So copy to file. We're going to save this request as a file, and then we're going to test it using SQL map. So we're going to call this request.txt. And then we're going to go to our console, make a bunch of tabs, and we're going to SQL map. All of my SQL map history has been deleted. Okay, get parameter, query might not be injectable. It's recommended to perform only basic union tests. Sure, let's go ahead and follow that. So it doesn't look like it could be, it didn't find an injection point, but there's another endpoint that we can test. And that was the endpoint where we actually made the post request. We made the post request to GradXT says, I think the comment relates to a person at Overthewire, so a shout out or greetings, maybe. Yeah, maybe. Okay, we got this post request over here as well that we can test. So let's go ahead and do that. So the query here is test, right? Let's save this to a file. So copy the file, request, let's call this request2.txt. Okay. And then let's point SQL map at request2. Do you want to follow? Let's say yes first. Redirect as a result of a post request. Do you want to resend original post data to the new location? Sure. So I'm not very hopeful that SQL map is going to be able to get us there, because all of the other SQL injections on the Natas CTF, they've never been solved by using, well, I haven't been able to solve them by using SQL map. But you know, there's a first thing for everything. Okay, so maybe we can't do SQL injection here. There are also a bunch of payloads we could do. How about we can also try SQL injection fuzzing with FFUF. I've never really done FFUF for, hold on. I need to change the music. How about we do some, we haven't done the Shadowrun soundtrack in a while. Okay, let's try this out. Okay, so let me see if I can find an article. So let's see, SQL injection testing FFUF. How I found multiple SQL injections with FFUF and SQL map. Okay, so FFUF wiki. Fuzzing the right way, integrating FFUF with other tools. How about we try the first article? Looks like, can we actually look at this article? Is it gonna stop us? Let's see, FFUF is a response time filter, if I'm not mistaken. Yeah, well, I've never really used it before. Okay, so we're not using FFUF yet. We're looking for parameters. Lowercase parameters, fuzz. Ah, okay. Man, this person sure loves using memes. Okay, so I guess what we need to do is we need to figure out the relationship between... Okay, I'm getting off track here, but who doesn't? Turd Ferguson, hello, nice to see you here. Great name as always. We're taking a look at this page. Which page? This page here from Natas, the Natas CTF. We need to figure out the relationship between what we search for and the token that appears in the URL parameter. So if we just do like a bunch of A's, then we get a really long thing like this for a parameter. But what does this actually, what does it actually mean? So echo out this thing. Let me base 64 decode it. It says invalid. What's invalid in this? Oh, it's right. So the reason why it's invalid is because this has a URL encoding. Okay, let's URL decode this thing first. So we would do URL decode. Still, this doesn't look like standard base64 encoding. It doesn't look like, well, I mean, Maybe we could feed this to CyberChef. I haven't used CyberChef in a while either. So should CyberChef... Okay, let's put this in CyberChef and let's just work some magic. So magic doesn't get us anything. Oh, maybe we should bake it. Nope. I mean, what could it be? Decoding from a bunch of different methods. I don't see anything super compelling here. Yeah, I'm not sure. Worst magic ever. Yeah, well, I mean, so single quote doesn't work. The comment out does work. Well, I mean, we don't know if it works or not. It could be that there's just nothing in the database that contains a dash. There is things that contain a dash. Oh, here's some new funny jokes. So, what's the object-oriented way to become wealthy? Inheritance. So if you are a computer programmer, this would be really funny to you. Let me know if you think it's really funny. Let's see. 2 strings walk into a bar and sit down. The bartender says, "So what'll it be?" The first string says, "I think I'll have a beer, quag, folk, berg, okay." And the second string says, "Excuse my friend, he isn't null terminated." Alright. What are some other ways to test? So maybe I can get some SQL injection payloads. Big funny, big funny. Okay, we need some lists from, let's see. The Bajaro 88, nice to see you here. Let's give you a fun video redeem. How about we give you some Nancat? Here you go. Okay, so it looks like we got some payloads over here on GitHub. Oh, this isn't a very long list. Well, we could try fuzzing this with FFUF, right? And we would do this in the post request. So we've already got the post request. So we can just grab this list and create this, we'll call it SQL short. And let's see. So we'll use FFUF with the request file, request2.txt, and we need to edit the request2 file then to include the fuzzing point. Nano request2. So we want the fuzzing point to be in the query here. Okay, so after we do that, FFUF, request is going to be SQL short. Oh, why did it not work? U flag. Oh, we need the U for. Wait, what was it? U flag or request flag is required. Oh, okay. So we need to put in the full word request. Let's see. OreoByte says we're not hacking live. We laughing live. Yep. OreoByte says you want my fuzzing list that I use? Yeah, sure. If you've got a fuzzing list that you use for SQL injection, I'd appreciate it. So let's see. Request. What is the flag again? Either W or input command flag is required. W. What? Oh, we need a W for the word list. Right. And we need to provide the... Man, I'm screwing this up. So this is request2.txt, and the word list is SQL short.txt. It looks like it didn't work because it doesn't show us anything. Yeah, we got 9 errors. I think we have to do request proto, I think. Request proto HTTP. Yeah, okay. So everything's the same except for this one. This one has a different size. Actually, no, they all have the same size. They're all 302. They're all size 920. And it looks like OreoByte sent me something by Discord. So I've got to open up Discord. Thank you for the list. Go ahead and open this up. Okay, so we got a really big list here. Let's select all. Copy. Second of Mind says, "Sup, sorry I stepped away for a bit." No worries, no worries. We're just doing more SQL injection testing right now. So let's see. Let's make this file oreo.txt. Okay. So this is the SQL injection payload list that OreoByte has suggested. See, these all returned 52 words, 920 size. Figure out the vector. No, I didn't figure out the vector. I think the vector might be the URL parameter that's created. So whenever we create, whenever we send our post request, we get a string in the URL parameter under the query parameter, and it looks like something that could be that could be a, what is it called? It looks kind of like a base64 encoded string, but it kind of doesn't look like a base64 encoded string. Second of Mind says, "To me it looks like some sort of serialization or padding oracle, since Java and UDP searches were very similar." Java and UDP searches. Java. Okay, this is a great joke. Anyways, let's go ahead and do some ads right now, because we got ads running on Twitch, so we run them on long pause, long pause. Grab the query strings for each string. Okay, we're just going to take a little break for about a minute. Enjoy the birds. We'll be back in about a minute or so. Sick the Mind says, grab the query strings for each search. Grab the query strings for each search. So I guess what we could do is we could grab the query strings for a few different searches to see how the string changes. Okay, so I think we're going to see our good friend Mr. Squirrel. Yep, here he is. You put stuff on the floor, you're gonna get squirrels. Okay, let's put the squirrels away. And let's figure out what these strings look like. So, let's see. Nope, this one. Okay, so first of all, let's search for... what would be a good test? So let's do empty search. So if we do an empty search, we get a result even if we send an empty search. When your hammer is C++, everything begins to look like a thumb. What? If it wasn't for C, we'd all be programming in BASIC and OBOL. Okay. I wonder what the commonalities between these three jokes are, because if we send the empty string, then we get these three jokes. Wait, do we get 3 random jokes if we submit the empty string? Keyboard not found, press F1 to continue. Nice. Okay, so the empty string... is the empty string the same query? Okay, let me start recording these. Let's just do basics... well, no, was it URL decode? So this is empty string. Let's see. We'll create a document. Okay, so this is an empty string, and we should probably compare it against another empty string, because they seem to be getting random jokes if you send an empty string. Yeah. Go to search with query param, nothing after it. Okay, yeah, I could try that for sure. A bright young coder named Lee wished to loop while I was 3, but when writing the equals, he forgot its sequel and thus looped indefinitely. Okay. Right. Let's well, okay. Let me just grab this query before I give that a shot. I'm just gonna URL decode this thing. I just want to make sure that it looks like the same string. This looks like the exact same string. Hold on. Yeah, this is exactly the same. So that confirms that. Wait, what? No, yeah, it looks like exactly the same string. Okay. That's confirmed. Sure. That GradXT asked us what happens if we just send an empty string to the query. Huh. 0 padding found instead of... Okay. So this is some sort of padding oracle attack, right? So I don't know very much about this. I've heard of this vulnerability before. So let me go to the AI and do some research. What does this error indicate? Could it be something we can attack in the database? So the error indicates a padding oracle vulnerability in cryptographic operation, specifically related to PicoCTF padding validation. So I do not know anything about padding oracle attacks. I've seen somebody do a demonstration on it once. I didn't quite understand it at the time. It was maybe a few years ago. So the application expected to be padded using PicoCTF standard, where padding bytes indicate the padding length. Instead, it found 0 bytes as padding, which is incorrect. This suggests that the application is explicitly checking for PicoCTF number 7 and may reject improper padding. So let's see. If the server behaves differently when padding is correct versus incorrect, different error messages or timing, it could be vulnerable to a padding oracle attack. This could allow an attacker to decrypt data without knowing the key. Okay. Encrypt arbitrary data. Okay, so I think what we need to do is we need to use this attack to get the password for the next level. So, okay. We need to use this vulnerability to get the contents of a specific file. And the specific file is, what was it? Etc. Natas webpass Natas 29. It should be Natas 29 because this is Natas 28, right? Yeah. I wonder if it has a suggestion for us. Okay, so we've identified the padding oracle vulnerability, and the goal is to read etc. Natas webpass Natas 29. We can proceed with the padding oracle attack. Confirm the padding oracle. Valid ciphertext but wrong padding. Okay, so when we're talking about padding, it usually refers to like output at the end of something. So do we extract the type of encryption used. So most padding oracle attacks use the AES CBC cipher block chaining. Check if the cipher block is in block of 16 bytes. So AES block size. The app uses PicoCTF number 7 padding, as the error suggests. Okay, so we found that this over here. Well, let's save this out. We need to figure out what the... oh, you know what? This does look like padding. Well, I mean, it looks like base 64 padding anyways. GradXT says you can figure out what bytes are being padded by giving it varying long strings and seeing what's the same. So we need to figure out what is the multiple of whatever strings we're getting, right? So if we were to echo this out without the new line, and we pipe it into word count, This is 108. I'm pretty sure 108 is divisible by 16. Is it divisible? Okay, echo 108. Is this modulo? Is this going to work? No. Actually, Python, we can probably Python it. Python command 108 modulo 16. Or actually, we need to print this. Okay, so this is divisible by 16. So we need to figure out if other strings are also divisible by 16. So let's go ahead and go back to the application, and then... I'm going to record this. Okay, let's get that other string. So what if we just give it A? If we give it A, it's probably going to give us the same sort of error. If we give it something that's divisible by 16, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1, 2, 3, 4, 5, 6. Okay, we get a different error message. Trying to access array offshoot on value type bool. Great. 0 padding found. Let's go back to the application and get a legitimate string. So here, let's I don't know, test, and we get this string right here. Let's record this. Okay, so this is... Let's figure out if this thing is divisible by 16. Okay, so we do echo n, pipe into word count. Huh. So it's not a fixed length. So sometimes... I'm pretty sure 124 is also divisible by 16. So whatever is there is always going to be divisible by 16. What was it? Python 124 is divisible by 16. Oops. Wait, what? No. Okay. Huh. No, it's not always divisible by the same number. That's unexpected. I expected it that I expected that it wouldn't be divisible, or it would always be divisible by 16. That's odd. Okay, so that was empty string, that was empty string, this is test. So I guess we could tab this to keep it nice and consistent. Okay. Let's do one more example. Let's do something really long. So we're just going to do all the A's. Java and UDP were good separate ones. Java and UDP. Let's do, well, I mean, UDP, I mean, this is a 3-letter search. So it's probably gonna, they just gave variation. Variation? Okay, I'm just gonna copy this. This was for the UDP string. So UDP okay, let's go ahead and figure out if this is going to give us something divisible by 16 or whatever. Okay, so echo 118. So the only consistency I see here is that they're all even numbers. Because is this modulo by 16? Yeah. It's not an even division. So what was the difference? Let me record how long these strings are. Okay, so empty string results in, what was it, 108? This was 108. Empty string, this is the same. So empty string is 108. Test is, this was 118. And test was, I think it was 124, if I do remember correctly. Yeah, 118, 124. And the first one was 108. So I guess the minimum length is 108. And let's feed it something really long and see if it comes back really long in return. So if we just do all of the A's, and then record this. Actually, you know what? I forgot to URL. Did I forget to URL decode those last few ones? Because if that's the case, then we need to start again. Yeah, I think I forgot to URL decode these ones. Huh. Okay, let's, yeah. Such is the life of the hacker. Okay, so it does become longer depending on how long the input is. So this is 216. 216, let's go ahead and do the modulo. So this isn't even. It isn't even with I mean, maybe they're all divisible by 8. Maybe that's the common denominator. Let's record this. Oh gosh, I forget the lots of A's. Yeah, I forgot to URL decode this first. And what was the length of this? I think it was like 208 or something, right? No, it's 216. Let me go back in. 216. And let me grab the other strings so that I can decode them first and then compare the results. Okay. Okay. And we're doing our echo. Man, the most exciting hacking ever. Okay, so this one was 108, and this was for test, I think. Yeah, this would have been for test. So this is 108 instead of 124. Let me change that in nanoqueries.txt. Let's get rid of this. So this is test, and we need to figure out the that was also 108. I'm pretty sure. Let me double check. Yeah, this was also 108. So if it's 108, then it's going to divide evenly into 16 because it's the same as the other one. No, what? (108) modulo 16 is... Wait, what was the empty string one then? I need to check that one again. Yeah. I thought... Okay. Let's instead of 16, let's modulo by 8 instead. Or wait. Is there another number that we should be doing all the division by? I thought 8 was the common denominator. Is it actually 12? So this is... Okay, let's go ahead and decode this. Okay, it looks like we got some padding at the end there. So it's probably... Okay. Echo this thing out. This is also 108. So this was UDP, and the length was 108. So it looks like it's either going to be 108. Wait. So it's either going to be a string length of 108, or it's going to be a string length of 216. So that's double. So if I go way overboard, is it going to be another multiple of 108? Is it going to become 324? If I give an absurd amount of A's? Let's give that. Let's put it to the test. Okay, so I'm going to take whatever this is, and I'm going to double it, and then we're going to search. And if this is actually dependent on the length of the string, with a minimum length of 108, it's probably going to be like 324. But I need to figure out after I URL decode this. Okay. 344. 344. So 216. Well, it's not double. Is it a multiple of 108? 108 plus 108 is 216. Plus another 108 is 324. But this isn't 324. It's 344. But is this... What is the common... What's the common denominator here? Is this a multiple of 12? No, it's not a multiple of 12. Is it a multiple of 8? It is a multiple of 8. Well, let me record this. So this was 344, and this was double the last one. Okay. So this one's 344. They all seem to have padding. There's padding here. What is the... They're all I think these are all divisible by 4, right? Well, I mean, if it's base 64, then everything should be divisible by 4. So let's try... So this is divisible by 4. This is also divisible by 4, I'm pretty sure. And... So all of the strings are going to be divisible by 4, and that's what this padding over here ensures. Okay, so Second in Mind says it's pretty easy to see that G plus through JP are the same. So let's see. So G until JP. This portion, right? So this portion's the same, this portion's... Yeah. So it looks like this portion is exactly the same for all the strings. So yeah, Second in Mind, it does look like, that does look like a pattern. So let me try feeding the application one of these strings without the padding and see if it gives us a different error. It'll probably give us a different error. Okay, so we go over to the application. Let's feed it a string without the padding. So it says 0 padding found. Trying to access array offset value type bool. 0 padding found, PicoCTF 7 padding. So let's just do... We were doing a little bit of experimentation, but let's go ahead and try searching for something. So PicoCTF padding oracle attack. Testing for padding oracle. I guess we could take a look at this. This is an OWASP article here. Padding oracle free exercise. I think a friend of mine gave this did this particular exercise as a demonstration for our cybersecurity group. Padding oracle attacks. So padding oracle hunter. Oh, interesting. This one's from Portswigger. Okay, let's take a look at this article. So padding oracle hunter is a Burp Suite extension that helps pentesters quickly identify an PicoCTF 7 padding oracle vulnerability. Okay. All right, we've got ads on Twitch, so ads on YouTube as well. And let's go ahead and put on the birds. How about these birds? Okay, so this is my favorite video of the birds. These are the fledgling stellar jays. We'll be back in about a minute. I'm just gonna have a little water break. Okay, so looks like we get to we get to research this this vulnerability here. What fun! Like I said, I've never done padding oracle attacks before, so this is some new stuff for me. I think there are probably a bunch of padding oracle attack scenarios in the Burp Suite Academy, so we might be able to take a look at some labs there. They might be able to help us out. Anyways, yeah, this is this is my favorite video. My favorite video. Okay. The Pajaro88 says, "Are we supposed to see ads or the birds?" After you see the ads, you're supposed to see the birds. That is the guarantee over here. Let's put the birds away, and let's continue. But yeah, I put on the birds for my mental health. They distract me from the terrible things happening in whatever I'm testing. Okay, so let's see. Currently, the extension consists of two separate tabs for PicoCTF 7 and PicoCTF 1 version 1.5, which support the following functionalities. Yeah. Identify and perform the padding oracle attack targeting PicoCTF 7 padding scheme on CBC block cipher. So this is probably a CBC block cipher that we're dealing with right now. Okay, so maybe we can look this up in the Academy. And we'll look up Pajaro88 says, "I'm here for the birds." Well, the birds will be here in another 30 minutes or so. They appear every 30 minutes. Let's see. Padding oracle attack? No. Oracle? No. Are there really no labs? Let's see. Actually, no, we need to view all of the learning materials. Okay, so padding. So there's nothing for padding oracle. No, nothing for padding oracle attacks. That's interesting because I really expected there to be something. Because they've got everything else. Anyway, let's go back to the AI. So the ciphertext is in blocks of 16 bytes. Check if the ciphertext is in blocks of 16 bytes. AES block size. So it turns out that the common denominator is not 16 bytes, it's 4 bytes. So let's see. GradXT says, Oracle, Java, it all comes back around. Is it? Is it all going to come back around? The app uses PicoCTF 7 padding, as the error suggests. Most padding oracle attacks target AES CBC. Blocks of 16 bytes. So these are not blocks of 16 bytes. Modulo 16. Yeah. So these are all... It looks like these are all blocks of 4 bytes. If you can intercept or modify encrypted data, use something like this, Padbuster. I've never... Well, I mean, I'm not familiar with padding oracle attacks, so I'm not familiar with the automated tools. Block size 8, AES 16, but Padbuster uses bytes. Bytes? Or we could do a manual Python one, okay. If you need fine-grained control, use a script like this. Huh. Okay, so I don't know. Sick of the Mind says, can ask it to add a feature to the Python script or pass it through Burp Suite so you can inspect after. Ask it to add a feature to the Python script or pass it through Burp Suite so you can inspect after. Okay, so this is the script that it's suggesting over here. We got base64, we got requests, and unit testing to find a padding buffer length. You know what? Sick in the Mind, you said something about all of the prefix. So everything at the beginning of these strings is all the same up until about this point. So I need to figure out what the length of this portion of the string is. That might give us a little clue. This is 42. 42 is, well, I mean, that's 42 isn't divisible by 4. Is this divisible by, no, it's not divisible by 8. It's not, well, I mean, maybe that doesn't really matter that much. But we need to find some sort of encoding scheme that creates definitely this prefix. That's just a known good start of the string. So we know that no matter what is passed to the application, the start of the string for the ciphertext will be this. I don't know if it's going to, since you know that the ciphertext always starts with this, it suggests that the encrypted data has a fixed prefix. Okay, sure. Likely corresponding to known plaintext, a header or magic number or a static part of the formatted string. Okay. Extremely useful for a chosen plaintext attack or adaptive chosen ciphertext attack, like a categorical attack. Okay, so the ciphertext is base64 encoded. Okay, sure, due to these symbols over here. So after decoding, it's likely an AES CBC cipher. So it's common in categorical scenarios. The fixed prefix suggests that the plaintext starts with something predictable, such as user equals, file equals, or Natas29. So decode the base64 to raw bytes to check the block alignment. Block alignment. Check the block alignment. What is block alignment? So we're checking the length of the decoded thing, and the decoded thing is... Well, you know what? We might as well try this out in Python. Where are we? Ask DeepTeaks to explain one step further. One step further. Just a second. I'm just gonna create this this test Python file with whatever code it fed me. We're going to check to see if it's multiples of 16. Okay, it says incorrect padding. So yeah, the prefix that we sent to it is not going to be correct because, well, let me go ahead and go in here. I'm pretty sure this was like what was it? 2, 3, 4, 5, 6, 7, 8, 9, 10. 3, 4, 5, 6, 7, 8, 9, 20. 30. 40. 1, 2, 3, 4. So 40. This is. No, it was 42, I think. So if it was 42, then we need to pad this out by 2, right? Okay, so Relax says, oh no, sorry. Second the Mind says you want to find the end in the beginning. The end in the beginning. Let's see. The multiples part is pretty useless here. Let's see. You want to find the end of the beginning. So Relax says, I think it means something similar to the offset from a byte. Not entirely sure here, though, because 42 is obviously not a multiple of 16. Second the Mind says, the thing about CBC is once a key is derived, the entire shifted chunks are decoded with the same key. Okay, once the key is derived, the entire shifted chunks are decoded with the same key. So if we can figure out what the plain text key is, well, I mean, it's kind of like XOR, right? So using XOR encryption, if we're able to determine the plain text, then we can decode any messages. Any ciphertext messages. You only need to determine what the padding is. Okay, let's go back. Check if it's a multiple of 16. So I think after we add the padding, it should be a multiple of 16. Right? Because still comes out 31. Okay, so let's see. Extract. Discern the cipher structure. Great. Okay. Decode the base 64 to raw bytes and check the block alignments. Extract the IV initialization vector at the start. The first block, the first 16 bytes, is the IV. Sammy. Sammy says, yo. Yo, Sammy, how are you doing? Nice to see you here. You know, we haven't done in a while. We haven't done a Hack the Planet. So we gotta do the Hack the Planet.
Hack the planet! Hack the planet! Shut up and get it.
Okay, so let's see. Check if the decoded length is 16 plus 16 times n bytes. If yes, extract IV decoded something something. Perform a block-by-block decryption via padding oracle. Since you have a fixed prefix, you can brute force the last byte of the first encrypted block to manipulate padding. Use the padding error 0 padding instead of PicoCTF number 7 to leak plain text bytes. So, Python requests. So we're making a request to what? Zero padding found in response text. So I guess we're going to be check padding oracle modified CT. Modified CT is whatever is in here. Can we do this manually? Okay, so we've got Natas 28 here. We can manipulate whatever is in here. So we know that if we send an empty string, then the resulting query over here is going to be have one. This is going to be 108. I'm pretty sure the length of the string is 108. If we take out one symbol, wait, it still returns. We took out the padding and it still returned. Hold on. So we essentially took out this portion here, and it still returned something. We took out the padding. Let me try feeding this to the application. Here it says that 0 padding found. You know, the reason why we're getting these errors might be because, yeah, we need to URL encode this stuff. Base64 padding is different from the PicoCTF padding. So the reason why this stuff isn't returning, well, okay. If we give the this 0, like string length of 0, and we start deleting this stuff over here, VTY7, thank you very much for following. You are now HackerFrog. Why don't you have a Nyan cat, because it's a meme that never dies. Okay, so when we start deleting some of the... Okay, so... Right. So GradXT is correct. Slyborg, hello, nice to see you. Thanks for using... Thanks for using my emotes. Wow. I'm glad I included my emotes. I really need to do more emotes on my channel. Because I haven't updated my emotes in like a year, like over a year, I think. Anyways, let's do it. Yeah. Oh no. What else do we have left? How about Jurassic Park? I love this movie.
It's a Unix system. I know this. It's all the files of the whole park. It tells you everything.
Okay, so let's see. Zero padding found instead of the PicoCTF 07 padding. So the PicoCTF 7 padding, right? I'm pretty sure... Does this all end in the same bytes? This doesn't... So these strings don't necessarily end in the same bytes. Because that wouldn't make sense. It wouldn't make sense if they all ended in the same bytes. We do know that if the length of the string is not a multiple of 4, then it'll be padded out by these equal signs. So that means that these are encoded using base64. We know that there's a certain prefix over here. But we don't know what the fixed portion... We don't know what the fixed portion could be. Okay. Decipher the full ciphertext to reveal sensitive data. Once you decrypt enough, you might find a serialized object. So something like this, or a file path or command that can be manipulated. If the plain text contains a file path, you can modify it to whatever we want. Okay, so they've got. I wish I understood more about these cipher block texts, or whatever encoding method they're using here. But sometimes you gotta press the I believe button. Let's see. Okay, so what's going on in the script? I'd like to understand as much as I could about the script. I can about the script before we just randomly throw Python scripts at the server. Okay, so we're sending this to Natas 28. And the URL parameter is search, right? Let me check that. The URL parameter is query. And let's see, Natas 28 dot natas.labs.overthewire.org. And this is the search endpoint. Search.php. Okay. The thing is that we need to send this with basic authorization. So we need to adjust the script to send the request with basic authorization. Let me look up how to do that. Python requests basic authorization. Basic auth. Okay, so we got wow, the AI sure does love to answer questions. Let's see. From request.auth, import HTTP basic auth. Okay, so username, password, URL. Let's. Anyways, request get URL auth equal HTTP basic auth. Okay. You know, one of these days I really want to do a deep dive on requests and do it natively if you're using requests. Yeah, so this is request.auth. Well, I mean, we've already imported requests. Let's see, it's... So the username is going to be Natas... Majsec, is that how you pronounce the name? Let me know if that is the correct pronunciation. Have a hack the planet, and welcome to the stream. You're in a HackerFrog.
Hack the planet! Hack the planet!
Okay, so the password is going to be what? Not at all, but don't mind. You know, if you could let me know how to pronounce, I like to pronounce names properly. I have to pronounce them properly when I can. So if you could let me know, then I could at least attempt it. Mike Sack. Awesome. Wait, do you know Chad B Noob? Let me know if you know Chad B Noob. Because I think, of course I do. Okay. I was asking about a particular program or a particular script that Chad B Noob was using to. He's my sensei. Request.get URL auth user pass. Oh. Wait. Does that mean? Hold on. So does it mean I don't need to include any of this? Yeah, what could you point me to that particular script, the one that that shows chat stuff in terminal? Because that was really cool. That was very, very cool. Okay, so let's go ahead and try out modifications that Sick in the Mind explained. Request.get URL and then auth equals user pass. So that's Natas28, and the password is, oh, it's this one. Okay, okay. Let me go ahead and copy that, because I really would like to use it at some point. It is very, very cool. Sick of the Mind says it's all going through your simple function. You can add that to your request.get. Okay, so this is, where's that password? So this is the username, the password. Let me get the password from my GitHub over here. You know, it's funny to think that the Natas CTF game started with get the HTTP source, and it ends well, it's not, it hasn't even ended yet, but it's it just gets so complicated. Let's see. Mike Sec says it's quite scuffed. I'm gonna get it updated. Yeah. Well, I mean, even if it's scuffed, I think it's a pretty cool script. Okay, so let's see. So our request is going to be to this endpoint here. Return 0 padding found in response text. The original CT, what does CT stand for? Ciphertext. Ciphertext? So the original ciphertext is this. And what is this? Which ciphertext are they using here? This is the one that ends in BMYT. Which one is that? This is the test one. So it should end in 8F6BMYT. Hold on. Yeah, so this is test. Mike Sex, I'm going to bail. I'm quite proud there are more hackers around I could check out. Awesome. Yeah, nice to see you come by, Mike Sec. Thank you, and and hope you have a good time. Thank you very much for following Omnipotence. I hope I pronounced that correctly. Hey everybody, why don't you all have a desert frog? It's the cutest frog in the world. Okay, you know what? Every time I do one of these levels, it inspires me to learn as much as I can about whatever vulnerability is here, just so I feel less dumb the next time I encounter it. So I'm going to try learning about padding oracle attacks in depth. Maybe we'll do it on another stream sometime. Okay, so this is the original ciphertext. The decoded ciphertext is what? Decoded ciphertext is base64.base64 decode original ciphertext. So I don't know if this is going to work. It should be URL encoded, then base64 decoded. And then you want to convert to ASCII hex. Okay, we got ads on Twitch. When ads come up on Twitch, we also do ads on YouTube. And then we play the birds. How about, man? It feels like every time we've got we run out of bird clips. Anyways, here are the birds. We'll be back in about a minute. Enjoy the birds and the music. Okay, so Sick in the Mind says URL encoded, then base64 decoded. URL encoded, then base64 decoded. Then you want to convert to ASCII. ASCII hex. ASCII hex. That way you can see the actual byte difference. Okay, so yeah, we don't see any of these guys anymore. These are the dark-eyed junco birds. I think they migrated north after the snow all melted. Alright, let's put the birds away. So decoded ciphertext. So these blocks, split into blocks, assuming 16-byte AES. Okay, so split into these blocks. So I want to see what the I want to see what the script's output looks like before we modify it, or if it even works if we don't modify it, because AI has a tendency to write badly written code. Let's check to see if it actually works first. So it looks like it's working. Well, I mean, it looks like it is running. There's no way to know whether or not it is actually getting anything interesting. The only way we could check is if we go back into the code. Well, let's go back into the code. Okay, found valid padding at byte something something. So it's sending 256 requests, trying to get the block after the initialization vector. So let's see. Sick in the Mind suggested URL encoded, then base64 decoded. So URL encode, is that, which library is that part of? Python URL encode. It's a function. It's going to be a function, but URL decode, then base64 decode. URL encoding. So URL lib.parse module. So encoding a single string, URL lib.parse. So we're going to have to import this library. Encoding a single string, it would be URL lib.parse.quote. Wait. Encoding a string. Encoding a dictionary. So URL lib.parse.URL encode params. So we would do Shell and Tell says, couldn't you monitor your own network traffic using Wireshark to see if it's working? You said encode instead of decode. You said encode instead of decode. We do need to right. We do need to decode. We need to decode, not encode. But I'm assuming that if we're using the same library here, it's probably just the word decode versus encode. So Shell and Tell says, monitor your own network traffic using Wireshark. So I don't think we need to go that far right now. I think what we need to do first is, where did I run the script? I ran it over here. So nothing came back. We need to adjust the script so that it is a little bit more. Yes, it's HTTP. Technically, you could use TCP/IP to watch the stream. TCP, I haven't used this tool before. Usually when I do stuff like this, it's going to be, oh, what is it called? TCP dump. GradXT says, apparently you can do request.utils.unquote. Request.utils.unquote. Okay, let me edit the code here first. So, let's see. URL lib parse. So decoded ciphertext is going to be, I'm pretty sure the application's not going to take this unless it's URL encoded. So I'm pretty sure we need to URL encode the ciphertext here before we feed it to the application, otherwise we're going to get an error. So the original ciphertext, we need to do the, I don't know, URL encoded ciphertext. It's going to be original CT, but we do, what was it? So according to Grout CT would be, well, if we're doing it with what Google suggested here, we would do urllib parts .url decode. Or actually no, it would be encode here, because we need to encode it before we send it to the application. But does this work for... Okay, so let's see. URL encoded ciphertext is this. Actually, why don't we print this? Why don't we make sure that this is all going okay? Let's quote out everything out. Let's quote everything out. And just run this thing. How do we quote? It's was it triple single quotes? Yeah, it was triple single quotes. Let's make sure that this is going okay first. So print URL encoded CT. Okay. Okay, that that didn't work. Type error. Not a valid non-string sequence or mapping object. So I think we need to use another... So this is a string, so we need to use another method, right? It should be quote urllib.parse.quote. Okay, let's try this. Quote was for encode, but we do want to encode this before we send it to the application, because the application only accepts stuff that's URL encoded. So this is the URL encoded version of the string. Okay. Okay, let's change the music. We can only take so much of this Shadowrun stuff. Let's switch over to some Valhalla. Okay, so this is nice and smooth, nice and smooth. Okay, so we've got this URL encoded stuff. That's great. Let's go ahead and debug this script some more. So I'm happy that this isn't a super long script, because otherwise it would take a really long time to debug. Okay, so we URL encoded this thing, and then the decoded from base64 would be decode from base64 the original ciphertext. So the original ciphertext, this is the decoded version. We can't feed this. This can't be a URL encoded string, because if it's URL encoded, it's not going to be able to decode from base64, which is what we're doing here. So what else do we have defined in here? So it's blocks equals. So the thing about this script is that we need to URL encode the string before we send it to the application. Second of mine says need to break it down to the byte level for padding. Break it down to the byte level. So are we saying that we don't just break it up into blocks, but we break it up into bytes? I'm not too sure what that would look like, or what the code for that would look like. So we're splitting this URL encode to base64 decode to ASCII hex. URL encode, URL decode, base64 decode, ASCII hex. Once you have it in hex format, you can break it into 32 character blocks, which are 16 byte blocks. Okay, so let's go ahead and separate all this first. What we want is URL decode, base64 decode, ASCII hex. So let's say ASCII hex ciphertext equals original ciphertext, but we need to actually wait. No, it's decoded ciphertext. So it's decoded ciphertext, and then we need to do the other transformation on it. So the other transformation is going to be ASCII hex. So ASCII hex is, let me look this up. So Python base64 string to ASCII bytes. Okay, so encode the string to bytes using encode ASCII. Decode base64 string is this. ASCII bytes equals this. ASCII hex bytes. ASCII, you want hex, not ASCII. Okay, so first we need to convert it into ASCII, and then we need to convert it into hex. So the first thing we need to do is decode to ASCII. So ASCII ciphertext is, actually we'll call this decoded ASCII. Write a function like this. Okay, so decoded ciphertext, and what do we apply to it? We apply base64 decode. Base64 string. And we need to decode this into ASCII, which is this part right here. that encode? Encode. Let's just do a little test. Print decoded ASCII. Let's see. Bytes object has no attribute encode. Did you mean decode? I think it should be decode, now that I think of it. ASCII codec can't decode this thing in position, ordinal not in range. This is a Python indentation moment. Wait, did I get the indentation wrong? I don't think so. Okay, so yeah, they're all running on the same level. Oh, no. What? I think I decoded CT dot base64 decode. This is base64, so we need to base64 decode. And maybe we just need to get rid of this. Incorrect padding. Incorrect padding. I sure do like decode debugging scripts. bin ASCII, return bin ASCII, strict mode validate. This one is a bin ASCII error. Okay, so let's just make sure that... So decoded should work, right? Decoded CT. Only need 3 lines I posted above to decode that. Okay, let me take a look. Okay, we'll try what Second the Mind has. What was the suggestion? Okay, we got, oh, this is a function, okay. All right, let's take a look at this function. So def decode chunk. Looks like we're using 4 spaces for each one of these indentations. And what are we putting in there? Blob string. Okay, so base64 equals URL lib.parse dot unquote blob. Raw equals base64 dot b64 decode b64. Return something for I in range 0, length of raw, block. Block is a variable that's just block equals 16. Block is a variable that's just block equals 16. Hold on. Before I let me fill in this right here. So raw I plus block. So do we need to define block in here as well? So block block equals 16. And does it need to be capitalized like this? Yeah. Blob being your variable original CT. Blob being your variable original CT. Okay. Type hinting your Python code fancy. Blob is the integer 16. Blob is the integer 16. Block is the integer 16. Okay. You can hard code 16 there if you want. I use okay. So blob is what? Bandit says I always use for loops. You can, up to you. Let's see. Blob is your variable original CT. So blob string. Okay, so once again, let's go ahead and quote everything out here. And then let's run the function. So decode chunk on original CT. You want to print or store the value of decode chunk. Decode chunk. Oh yeah, we want to print this. So just wrap print around everything. Let's see if this comes back. Or if I have a syntax error or a spelling error or something. I see a spelling error. Okay, hold on. Save modified buffer. Let's save it first. And then let's go back in and modify that. Okay, make sure that there's no other syntax errors or spelling errors in here. Then run the darn script. Invalid syntax. So return. What should the syntax look like? For I in range. You want them square brackets because it's list comprehension. Square brackets. Square brackets. Oh, you didn't close. I didn't close? Open, open, close, close. Open, close, open, close. In the return statement. In the return statement, return open, close, open, close. Block. Oh. Hold on. Oh, I see it. I see it. Like this, right? No. That needs to be there. Okay, so okay, let's try it out. Okay, now it's complaining about brain go brr in the wee hours. Yeah, I'm definitely feeling it, and it's not even the wee hours for me yet. So it says, what's wrong with this error right here? Bin ASCII error, incorrect padding. You already URL decoded your string. You already URL decoded your string. URL lib parse unquote. Well, I mean, raw is base64 is unquote the blob. So the blob is decode chunk original CT. Original CT is this. So this is already decoded. So we don't need to do this. So base64 is going to be, well, it's just going to be blob, right? In this case. It honestly be easier to re-encode it. So the base64 is just going to be the blob. You need to send more payloads to the server. Eventually. So you can find the padding. Okay, so we need to put that back into place. URL lib parse unquote. So the blob is going to be, oh, in that case, we have to URL encode URL encoded CT. So that means that we needed to decode chunk with the URL encoded CT. URL encoded CT. It says incorrect padding. Bin ASCII error. You know, I'll check with the AI, maybe it can help me debug. What was the name of this sort? Oracle. What did I name this thing again? Oracle check. Okay, we got ads on Twitch, so we do ads on YouTube, and let's go ahead and clear our minds with the Stellar Jays. Okay, we'll be back in about a minute. Struggle, struggle, struggle. Okay, let's refresh our minds. So these birds have their mouths stuffed, but they can't fit any more peanuts in their mouth. But they're trying. They're trying so hard. They're trying to pick up peanuts, but their mouths won't close. Oh, I managed to get one. Okay, let's put the birds away. Fresh videos this summer? That depends on Relax's bird. Yep, those are birds. GradXT, yeah, maybe. Well, depends on how good the footage is. I'll see. I'll put up the bird bath again, and I'll start filming it. See if we can get some more baby birds having a bath. That'd be really fun. Okay, so let's see. Oh, let's get the whole thing here. Okay, so let's go ahead and get to the AI. We'll try to get it to figure out why we get this error message here. So this is the script snippet we're working with. We get the following error message. Friendly Creative Seal. Hello, nice to see you here. We're using AI, that's correct. We're using some AI to help us debug our code. Why does it keep on telling us there's incorrect padding? Okay, so the error occurs because you're trying to double encode the ciphertext. Base64 decode twice, but the decoded ciphertext is not Base64 encoded the second time. Okay, so what we need to do is remove decoded ASCII equals this. Decoded ASCII, the ciphertext is only Base64 encoded once. Okay, so first of all, we need to get rid of this decoded ASCII variable. But we don't use the decoded ASCII variable. Let's quote it out. Decoded CT. So it's decoded CT is Base64. Oh, you know what? I forgot to remove that that print statement there. Okay, let's run the thing again. Okay, so we're getting somewhere. So these are bytes. These are hex encoded. These are hex bytes. These are hex bytes of the parts of the string, right? And what we need to do is, let's see, Sick in the Mind says what we need to do is what? Find the padding. You need to send more payloads to the server, re-encode it. Okay, so what did the AI suggested some fixes here too. So they suggested check padding article, padding oracle. Let me see if I can make this bigger. Okay, so check padding oracle modified CT. Response equals return something something. Huh. Did it modify? Blocks equals split into blocks. Print blocks for block and blocks. Now that you have the correct ciphertext structure, okay. So we tried doing the decode chunk with the URL encoded ciphertext, and so I guess we don't need. Okay, so let's leave this as is right now. So the AI suggests check padding oracle with the modified ciphertext. So modified ciphertext is the ciphertext that has been... Wait, where's the modified one? So check padding oracle... They don't... They don't run the function in the script. Oh, okay. So wait. So they actually do run the function in this last part here. The fixed prefix suggests that the plain text starts predictably by manipulating ciphertext blocks. Okay, so let's try what this... We'll call this something else. We'll call this... OC2. And it's not only it's not only this, but there was some extra stuff that it added at the end as well. Sick in the Mind says, "Here's what I wrote up for inspecting the responses for padding." Okay, we got some paste bin. Okay. You'll have to take it to the next step. Hold on. So let me just get this thing ready first. Then I'll save it out. And then we'll try Sick in the Mind's script and see what's going on. Okay, so we're gonna call this one Sick in the Mind. Sick in the Mind.py. Let's try to understand what's going on here. So this is Python 3. It's not Python 3 because it's default Python 3 in Kali Linux. We've got the requests, we got some URL lib parse, we got some base64, and we got some system. We've got the hopefully correct passwords for Natas 28. And this isn't the URL path. So the URL path is not going to be index.php, or is it? No, it should be query.php. Search. It is index.php. Oh right, because we send the whatever. Wait, are we sure we want to? Okay. Let me. Where are we? So search.php is where we're sending this stuff, right? Post request goes to index. Oh, it does go to, well, hold on. Search.php is a location forwarder. So index.php. So this is, I mean, this is the landing page. So the post request does go here. So whatever we're sending, so test, for example, this does, it does end up at search.php. So what are we looking at? So index.php, we're sending a post request. So where do we send the post request? If name equals main, then print, man. Post goes to index.php with parameter query a for query equals a. So the request response includes a location header and redirects you to the request to the query equals encoded payload. Okay, so where's the... Where's the request? Oh, sorry, the request is way up here. No. Oh, okay, so get blob has the request in it. Yeah. So the URL, the authorization is this stuff here. The block is 16, max n 16, get blob, n integer, toString. Payload is going to be the query, a times n. So we're just sending a bunch of a's. Okay, so let's see. Request post to the URL. Authorization equals auth. Auth is this stuff over here. Data equals payload. Payload is query a times n. Allow redirects false. Location equals r. Request headers get location. Return equals location.split query -1. -1 is, we only need the location header response, we don't need the redirect. Okay, we've got the decode chunks. So get blob, we get the thing with this function here. Then we do decode chunks, blob string, which we wrote out before, right? What I don't quite understand, what I don't quite understand is this this printf stuff over here. Oh, pretty table stuff. First number up to 16 characters, send an incremental A to find the padding changes. A. Blob equals get blob. Chunks equal decode chunks. Lengths equals length of bytes. Join the chunks. We'll see when it runs. Turn each chunk into its hex fingerprints. So hex is equals for C in chunks. This row. Well, okay, so we've got 16 blocks. Now, these are hex bytes, right? Way less cool since it's broken up across lines. I'll be honest, and I'll say that I still don't really understand what the heck is going on. but these are hexadecimal representations of bytes. But I don't know how we determine what the original value was. Pay attention to block 3. Block 3. So this is everything. Hold on. Okay. Let's just... This is block 3. It's made up of 1, 2, 3, how many segments? Strength of text. Okay, so we're fitting it all on one line here. Not line 3, block 3. Isn't this block 3? Okay, let's run the script again. Oh, okay, this looks much nicer. Okay, well, let's make it even. Let's make the text even smaller. Okay, so we need to make it even smaller to fit. Okay. Man. Notice a pattern. Huh, what happened? What happens when we get to 14, 15, and 16? Oh. So after it goes past a certain length, then the number of bytes increase, and then we have to add on. Okay, so what we're supposed to pay attention to is block number 3. What happened to block 3? So after a certain length, it all becomes the same. Block 1 is always the same. Block 2 is always the same. Block 1 is always the same. Block 2 is always the same. After 10... After a length of 10, then block 3 changes from dynamic to static. So are we going to see... Block 4, block 5. So there is a block 6 after 13 bytes. Well, I mean, after the length of the string is 13. Right? I'm assuming that n is the length of the payload that we send it, like the number of A's. Okay, so we're supposed to pay attention to block 3. Block 3 becomes fixed after the length of the payload goes beyond 9. So from 10 onwards, block 3 becomes fixed. So what does that tell us about the plain text? I need to do a deep dive. I really need to do a deep dive on padding oracle attacks so that I feel less dumb when I'm dealing with this stuff. Okay, so our good friend Sick in the Mind says pay attention to block 3, which is this. We definitely see that that there's a change in the pattern after the length of the payload goes beyond 9. But what does this mean? So try special characters past that block. Special characters past the block, as it may be attempting a block-based comparison. Block-based comparison. So we're talking about a payload that is over the length of 10 and contains special characters over 9. So 9, which means 10 and above. Okay, we go back. If we go back to the script, let's see. Signamine says 10 plus would be past a hard-coded buffer that's filtered. So try adding 9 A's and the single quote character. Okay, so the payload is this. So A times N. So A times N. So we can just directly modify this so that it's not times N. It's just A manually, yeah. Oh, you mean... Are you talking about in the application? Oh. Times N. Okay. Okay, let's go over here. Like this. Grab this thing, URL, decode it. Hold on. I want to do something to this. So we want to feed this into what? Man, my brain is so fried. Okay, let's just do a Python console. Okay, so import, what are we doing? Okay, we got our string. And this would count as the blob, right? So we would decode chunks on new string and print that out. Actually, we need to provide it with the URL encoded version of the string. Man, okay. Okay, so that means we need to just get the URL encoded version. Okay, let's try running the script. Unexpected indent. Oh. Where's the... Oh, okay. Oh, because we've got this thing twice. Okay, let's just remove this portion. Okay. So these are the bytes. So we want to take these bytes and we want to... What is this JZ thing? So these are the chunks, or the blocks. So block 1, block 2, block 3, block 4, block 5. So there should be... Because this payload is 10 characters long, there should be only 5 blocks. So this is block 1, block 2, block 3, block 4, and block 5. What we want to do is we want to compare this with this output over here. So get blob, decode chunks. Decode chunks, lengths, hex fingerprint, hexes for C in chunks. My brain's turned to mush. So when we print this out, it's not super... Okay, we got ads. Let's ads, and let's heal ourselves with some birds. Okay. Alright, we'll be back in about half a minute. We need to compare. We compare, we need to change... What were we even doing? Okay, so we got the output for this particular string. We need to translate this into... I mean, we could just manually translate this. It wouldn't take too long. Let's see. Let's just call this test string. Okay, so first block is what is it with these weird looking characters? I thought this was supposed I thought this was supposed to be hex. I mean, if it's... Hold on. Let's not save this. If this is just supposed to be hex, why are these really... Why are these, what are these special characters doing in here? Did I skip the URL decode? Did I? Let me check the script one more time. So I did, well, I put in the new string over here, and then we did decode chunks on the new string. So decode chunks, that does the URL decode. So I'm not sure why we got that weird... I'm not too sure why we got that weird stuff in the output after we did the decode chunks. No idea. I mean, let's run the script again. Why does this stuff appear? So I'm assuming that it's just going to be hex E8, but for some reason we see weird characters like this and weird characters like this and double backslashes. So I'm not too sure what actually happens. Like, and we have a random single quote. Okay. Well, I mean, I feel like we're on the way to something, but I'm not I don't think I have the skill set. I don't have the skill set to see this through to the end, because although I understand that we're looking for a pattern, and I understand that the first blocks of this ciphertext are going to be fixed. Well, the first two blocks are fixed, And then after we send a payload equal to 10 characters, the third block becomes fixed as well. And after a length of 13, then we have to add an extra block. So what else do we know about this particular application? We know that it's using PKS. What is it called? PKCS padding. And then it complains if we don't URL encode whatever payload we're sending to the application. And it also complains if we don't zero padding. So after a length of, how many characters is this? I mean, this should be fixed, right? This should be 16. This is 16 characters, but it's 32 bytes. So that means well, we got the padding right here. So the padding's right here. This is one character. And then after this, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Zero padding. Actually, you know what? We could try. So this is removing one character because this is the equal sign. It's still okay for PKCS padding. If we remove one more character, then it complains. So that's 2 characters. That's 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. 22. So after we remove 22 characters, then we get a different error. And the different error is incorrect amount of PKCS 7 padding for block size. So that was 22 characters. 23. 24, 25, 26, 28, 29, 30, 31, 32, 35, 36. Huh. Okay, well, okay. At this point, I think I really want to try some sort of automated tool. And then after I use the automated tool, I can go back and I can discover what exactly is going on with the gosh darn app. So let's see. Padding Oracle attack tool. Padding Oracle Hunter. Automated padding Oracle attacks with Pad Buster. Pad Buster. Advanced padding Oracle. So we've got some some GitHub projects over here. Oh man. Padre. Padre is an advanced padding Oracle attacks against CBC mode encryption. So blazingly fast concurrent implementation, decryption of tokens, encryption of arbitrary data, fingerprinting of padding oracles, automatic detection of cipher block length, hints if failure occurs during operations. Padre will hint you about what can be tweaked to succeed. Okay. So sick in the mind, are you still here? If you could figure this out, I don't know if this is something you want to do for fun. But if you wanna race me to a solution and then and then and figure out what the heck is the actual solution, because you seem to understand what's going on a lot more than I do. Okay, so let's see. What do we do to install the thing? Fastest ways to download the precompiled binary for your OS. Let's take a look at the latest releases. So what I'm really dreading is that one of these days I need to do demos for all of the levels of Natas, and I think after a certain point it's going to require me to do a lot of research to understand what the heck is going on. Okay, so we got Padre for Linux AMD 64. Sure. Let's download this thing. wget. Okay, so what's going on over here? So usage scenario. If you find a suspected padding oracle where the encrypted data is stored inside a cookie named SES, you can use the following. So what are we feeding to the target? We're feeding it. What are we feeding to the application? So we need our URL. In this case, it's a cookie, but we're not looking for the cookie in this case. So in this case, it's in a URL parameter. So Padre will automatically fingerprint HTTP responses to determine if the padding oracle can be confirmed. If the server is indeed vulnerable, the provided token will be decrypted into something like this. You can attempt to do so first by generating your own encrypted data so that the oracle will decrypt back to some sneaky plaintext. Okay. This will spit out another encoded set of encrypted data, perhaps something below if base64 is used. So you can now open your browser and set the value of the session cookie to the above value. Loading the original Oracle page, you will now see you are elevated to admin level. Okay. Impact of padding oracles. Full usage options. Okay. So we need to go over the tool to see what the heck is going on. Binary data is always encoded in HTTP. Tweak encoding. Okay, so in decrypt mode, encrypted data. In encrypt mode, the plain text to be encrypted. If not passed, it will read from standard in. We need to provide a URL. We need to select which mode. We need to get a regex pattern. Cookie post. String data to perform post requests. Uses the $ character to... looks like we need to shrink down the text to read everything. Okay. And even here, number of parallel HTTP connections established to target server from 1 to 256, 30 is the default. Block length used in Cipher, use 16 for AES, omit to perform automatic detection. Supported values, 8, 16, 32. Content type for post requests. If not specified, content type will be determined automatically. Can we just point this thing at the application and have it work? I don't know if it would be that easy. Okay, so cookie value to be sent in HTTP requests. So we use basic auth for this particular application. So I don't know if this program supports basic auth. No. Well, okay. So here's an example here. The example is in this scenario, it's assuming that content type for post requests. Can we feed it custom headers? Because that would be nice. Okay, so padding oracle, tac, padre, basic auth. I mean, this is Padre. CryptoPals exploiting. This is a write-up. This is a write-up for CryptoPals. Here's the thing, everybody. Padding oracle attacks require me to understand stuff about cryptography, and I know next to nothing about cryptography. This is one of the areas of cybersecurity I really wanted to learn more about, and I hope to get there eventually. But the thing is that this is very difficult for me. Oh, we got exploit. Let me take a look at this article. Okay, so we got another automated tool. So this is called Padbuster. Automated script for decrypting AES. And we got Padre. And I'm afraid I'm going to have to lean I'm gonna have to lean pretty heavily on the AI to help me out here. Okay, so the AI provided us with this script over here. So Oracle check 2, I think we saved it as. Okay, so decoded ciphertext in hex. How do we turn this into something we can actually use? So this is a script we used. Okay, so we use the script. We got this result. Since the, what does it say? So since the modified ciphertext still returns true, meaning the server still detects incorrect padding, this suggests that the flipping of the last byte of the first block did not produce valid PicoCTF 7 padding. This gives us valuable information for the padding oracle attack. Understand the expected plaintext structure. So the prefix, this thing, likely corresponds to a predictable plaintext such as query file user Natas 28. We need to determine the exact plaintext structure to manipulate it. Confirm that the oracle works properly. Since flipping the last byte didn't produce valid padding, try flipping different bytes, testing different blocks, automate byte by byte decryption. We can use the oracle to brute force the plaintext one byte at a time. So this is the problem. I don't understand the theory that goes into these kind of this kind of cryptography. So I just have to believe the AI when it gives me all this code. I'd like to be able to do some research on this and understand better what the heck is going on. But with my current level of education, I don't have the ability to understand what the heck is going on. I really wish I did. So I think I'm gonna have to. I think I'm gonna have to give up on this. Because even though I could potentially run the script that the AI is handing me, and I might be able to get it done eventually, I don't fundamentally understand what is going on, and that makes me feel bad. So I might have to come back to this level after I do a lot more research on cryptography and this kind of attack, this kind of padding oracle attack in particular. Right now, I think what I want to do is I want to get some tutorials so that I can try them out, and then I can come back to this after I understand what the principles of how this kind of this kind of vulnerability works. So I'm really surprised that there's nothing from Portswigger that covers this. Maybe if I search inside the Portswigger website, I might be able to find something. Let's see if I can Portswigger Padding Oracle attack. So we got Padding Oracle Hunter, Portswigger, Padding Oracle Hunter. Let's see. Cypher Enigma says you can probably find a Padding Oracle challenge in a Reddit for a CTF. It would be nice if I could find a few different examples for CTFs, especially stuff that I can access easily, and then I can try out some of these attacks, and then I can come back to this example. What I think is... Oh, wait. We've got a lab here. Wait, do we have a Portswigger lab? Because that would be really cool. Okay, authentication bypass via encryption oracle. So the lab contains a logic flaw that exposes an encryption oracle to users. To solve the lab, let's see. This vulnerability, gain access to the admin panel and delete the user. Okay, so we've got... Okay, so I'm gonna add this to my list of stuff that I need to take a look at. Because, you know what? I've encountered this before. So, another level in the Natas CTF lab really kicked my butt. And it was... Which one was it? So I think it was a couple levels ago. It was like level Natas 26 or something. So, you know what I'm really learning? I'm learning that the Natas CTF labs are a really great education resource. I think it was Natas level 26. This one was, yeah, the insecure deserialization level. And this really got me motivated to start learning about insecure deserialization because this challenge kicked my butt. Anyways, we've got some ads running on Twitch, so let's go ahead and run them on YouTube, and let's put on a bird video. I really appreciate the help that everybody was trying to give me, especially Sick in the Mind. Sick in the Mind was trying to guide me through. Of course, it's really hard for me to understand this stuff right now. Let's put on the bully bird, because I feel like I'm being bullied by this challenge. Okay, we'll be back in about a minute or so. I'm just going to take a little water break. This poor bird. Okay, so let's put the birds away, and I'm going to start collecting these labs for me to try out. And after I try out the labs and I understand what the heck is going on with the Padding Oracle attack, let's see. Cypher Enigma sends a link. Meta CTF, okay. Flash CTF this year. Meta CTF had a Padding Oracle problem this past month. Okay. Let me take a look at this. Okay, so let's see. The challenge involves... Oh, let me put it on screen. Okay, Flash CTF the SEER. Oh, this is a write-up. Great. The SEER challenge involves hacking a cryptographic vulnerability known as padding oracle attack. The attack allows an adversary to decrypt data encrypted with block ciphers in cipher block chaining (CBC) mode without knowing the encryption key. The attack takes advantage of the way padding is held in CBC mode, specifically when using PicoCTF padding. So this looks like it is kind of similar to the environment that we're looking at right now. Dagger RB. Hello, nice to see you, Dagger RB. We haven't been using enough of our redeems. We need more of these video redeems to keep us upbeat. How about some Hack the Planet just to remind us?
Hack the planet! Hack the planet! Shut up again.
Okay, so this is great. I'll be reading this, and let's see if there are some other labs that we can look at. How about, I think there was one from Pentester Lab. Padding Oracle. Okay, so this one is from Pentester Lab. I haven't taken a look at very much from Pentester Lab. I need to investigate this platform some more. Okay, let's I think I have an account at Pentester Lab. This is another platform I should probably consider more about using because they got free stuff. And let me see if I can locate my password. Okay, so everybody, I'm going to mute for a second while I punch in my my password for my password manager. This is, you know, what is it called? OPSEC. Don't want my password to be recorded on the mic. Okay, so let's see. If it ain't private, let me see. Yeah, of course. Anyways, let's see. Pentester Lab? Pentester Lab. Yeah, I've got an account there. Let me see if I can log in and take a look at what's at the free level. Okay, let's log in. Man, this challenge has made me feel really dumb. But sometimes the only way to move forward is to feel really dumb beforehand. Hold on. Need to change the music. Let's put on our FTL now. Okay, so let's take a look at what we got for free in this. So they've got a pretty good explanation over here about cipher blockchaining. So we got cipher blockchaining, we got padding. Wow, this is really nice. Dagger RB asks, what coding languages do you know? So I know a little bit about... I'm most comfortable using Python. I don't consider myself all that great with Python. I know the basics. And I'm picking up some of the basics of C. And I've been exposed to a lot of PHP code. So I can kind of parse out what's going on in PHP code. Kind of. And that's that's about the extent of what I got going on. I've also taught myself how to read some assembly, or x86 assembly in particular, because I use x86 assembly to do stuff like binary hacking and reverse engineering. Do I know HTML and CSS? I know enough HTML and CSS to take a look at basic web pages and try to understand what's going on. But I wouldn't say I'm an expert at that stuff either. Okay. Anyways, let's go ahead and look for the free stuff on here. Can we check? Can we search by... Can we search by free? Okay, so now we're search. Filter by... So let's just get everything, and we'll filter it by free. Not pro, free. And let's see what kind of stuff we've got here. The problem with this, with the layout of this website, is that a lot of it is not labeled very well. It's just called recon, you know, like recon number, and it doesn't tell you what you're going to learn in the particular module. So that kind of, that's not very user-friendly. Introduction to code review. Let's see. Padding Oracle. Yeah, we were taking a look at this. XML entities. This is cool. Definitely need to learn more about this. Looks like there's a lot of stuff here. Web for Pentester exercises a set of the most common web vulnerabilities. SQL injection, Linux host review. Okay, so this is all the free stuff. Well, I'm glad that there's at least one module I want to take a look at. Let's see if we can find some more stuff. I'm pretty sure, well, I mean, if PicoCTF had this, actually PicoCTF might have an exercise that has padding Oracle. That would probably be in the cryptography section. So it would be called like pad or Oracle or something. Let's see if we can find scrambled RSA AES ABC. Probably wouldn't. This is the thing. Cryptography is my least. It's the, what is it called? It's the specialization in cybersecurity where I have the least experience. So I guess I should really be interested in learning more about anything cryptography related. The thing is that there's a lot of math involved in cryptography, and I'm not very good at math. I suppose I could, I can teach myself how to do this stuff eventually. Oh, okay, I think this might be it. So no padding, no problem. So this is a PicoCTF. Oracles can be your best friend. They will decrypt anything except the flag ciphertext. How will you break it? Okay, let's record this challenge over here. This can be another thing that I research to learn more about this darn vulnerability. Okay. No padding, no problem. Let's see if there's anything else. It's probably not going to be more than one. Or is it really that? Substitution. Read my cert, hide to see. Oh, we've got another one. RSA Oracle. Okay. Alright, let me copy this one as well. Okay. And maybe there's something on Try Hack Me that could help me out as well. So we're just going to go over to good old Try Hack Me. I had a feeling that that the Natas CTF level was going to kick my butt today. I was completely correct. Okay, let's go learn. Let's search up this topic. Okay, so we got padding oracles. This is a premium room. I think I might have premium access for another couple days. So attacking ECB oracles. Let me copy this link. Okay. Advanced SQL injection, SQL fundamentals. Looks like there's not very... Oh wow, insecure deserialization. They've got a room. I should probably check this out. Okay, everybody, if you've got a topic that you really want to learn about, let us know in the chat, and maybe we can help you find some resources, or maybe I can point you towards some exercises that can help you out. Session management, static analysis, brute force heroes, SQL injection lab. Okay, so let's not go overtime for too long today, because I need to get some work done before I finish up for the night. Let's see, Python 10T. 10T is asking about Python. IPSecRocks is also nice for looking up topics. 0 Day. Hello, nice to see you here. 0 Day 3301. And 10T Rakan says, 10T Rakan asks for Python. Yeah, I can point you towards some Python resources. So let me... Okay, so everybody who doesn't know, HackerFrogs has a Reddit. And the HackerFrog Reddit has all of the schedules for our live streams over here. And we also have a few different threads talking about some learning resources. So, learning resources, Python. And we've got these courses over here from Skills for All. And these are Python resources in this thread over here. So we got Python Essentials 1 and Python Essentials 2. So these are by far the best. These are the best courses for learning Python, and they're free. So they're free. They're also backed by Cisco, which is a really big company. And this is essentially like 50-something hours of content on Python. When you finish it, you should be pretty good with Python. Well, not pretty good, but you know, you'll know your stuff, the basics at least. 0 Day says IPSecRocks also has nice lookup topics. Anyways, I've left the link for the Python Essentials 1 course in the chat if you want to take a look at that. And let's go over to IPSecRocks. Let's look for padding Oracle. Let's see, perspective, overflow. So these are all padding Oracle Part 1, padding Oracle Part 2. No worries, 10T Rakan. 10T Rakan, thank you. I mean, no worries. Let's go ahead and... So let's see, got overflow, rope, lazy. I wonder... Two-part IPSec video, buckle up. Huh. Or do these go to separate? Yeah, they go to separate URLs. Interesting. Kingpin Chicken asks, best route to learn pen testing. Best route to learn pen testing. Are you looking for network pen testing, or are you looking for web app pen testing, or are you looking for both? Let me know if you're looking for what kind of pen testing you're looking for, because even in pen testing, there's a lot of specializations. So there's web app pen testing, network pen testing, there's cloud pen testing, there's, what else is there? There's physical pen testing, but the most in-demand field for pen testing right now is either cloud pen testing or web app pen testing. So if you're looking for web app pen testing, what I would suggest is learning over at the Portswigger Academy, and this is going to teach you a lot about... Actually, Kinping Chicken, why don't you tell me what you know right now? Depending on where you're coming from, as far as your education, your previous education is concerned, I might be able to help you out. Because if you already know a lot about app development, for example, then your route to learning about pen testing is probably going to be different. Let me know what you already know, Kingpin Chicken, and then I'll give you. Then I can give you a better set of advice. Kingpin Chicken says, not very much, just started a few weeks ago on random stuff. Okay, so I would suggest you start with PicoCTF. PicoCTF is really good for beginners, and I've got a playlist on YouTube that covers this stuff. So the Shy Hat, that's my name. The Shy Hat YouTube channel over here. If you want to start at the very beginning, then you want to look at the PicoCTF challenges. So I've got a playlist over here. Where is the beginning of the playlist? Here. So we've got 96 videos over here that cover some different challenges. So if you find that the beginning challenges are too easy, you can skip them. But let me provide the playlist over here. So that's in chat. What was I talking about? Oh yeah, so the IPSec videos. Let me go ahead and take a screenshot of this. So I'm just gonna use my good old green shot to take a screenshot, and then I can look this up later. Okay. And what else? I'm pretty sure, yeah, the thing is that padding Oracle is not a super common web app vulnerability, or there are not very many CTF exercises I can use to look up, unfortunately. Okay, so let's go ahead and find somebody that we can raid on Twitch. I guess the other thing we can do is we can look at the InfoSec streamers list. So InfoSec streamers is a great list of different people who do streaming on YouTube or Twitch, and they do cybersecurity content. So that's the link, and it looks like Natas is on right now. So let's go ahead and raid them. Okay, so first of all, we should probably check to see that they haven't been streaming for a really long time and they're not about to end, and then we can send everybody over there. Cyphernigma says it's no SQLI, but it's still probably more present in CTFs than in the wild, right? I have no idea. Let's see. Natas is gaming and talking about some Linux. Asking me about free courses in our Discord. Okay. They've only been streaming for about 38 minutes, so they're probably going to be going for a while. But the problem is that they're gaming right now. But you know what? Even if they're gaming, you can probably ask them about cybersecurity stuff. So let's go ahead and raid them. Techno says, great stream. You know, you say great stream, but I was banging my head against the wall for about 2.5 hours straight. But thank you very much for the vote of confidence. Zero Day says, thanks for your work. It's amazing good. Wow. Thanks everybody. I guess you guys like seeing when I'm having a bad time, but I guess it proves that that it's not all sunshine and rainbows. Okay, let's go ahead and raid Natas. And before we go out, let's do a Hack the Planet.
Hack the planet! Hack the planet! Shut up and get it.
Okay, everybody, when you arrive at Natas' chat, if you could give this raid message, OSFrog, hip hop hack, OSFrog, I would really appreciate it. Thank you, everybody. We'll be back on Friday, and we're going to be doing more education stuff and more demos. See you next time. HackerFrogs out.